रोल नंबर 22।
यस सर।
हाँ मैम, एक मिनट, सर अभी ज्वाइन हो जाएंगे।
ओके सर।
इंट्रोडक्शन झालं तुम्ही चालू करून टाकायचं. यस मैम, स्टार्ट कीजिए सर, ज्वाइन हो चुके हैं.
ओके सर। A very good afternoon, everyone. Respected chairperson, resource person, and dear participants. I am Professor Zinira from Department of Physics at Mahatma Gandhi Vidya Mandir's Arts, Commerce and Science College, Malegaon City, Autonomous. It is my great privilege and honor to introduce today's distinguished guest speaker, Dr. Bhaskar R. Sathe sir. Dr. Sathe is a professor in the Department of Chemistry at Dr. Baba Saheb Ambedkar Marathwada University, Chhatrapati Sambhajinagar. He is also the coordinator of the Department of Forensic Science and head of the Department of Technology, reflecting his strong academic leadership and multidisciplinary expertise. He completed his MSc in chemistry from Dr. Baba Saheb Ambedkar Marathwada University and earned his PhD from the National Chemical Laboratory, Pune, one of India's premier research institutes. He further enriched his research experience as a Fulbright Nehru postdoctoral fellow at Rutgers University, USA, which is a remarkable international achievement. Dr. Sathe's research work focuses on advanced nanomaterials, energy conservation systems, electrochemical sensors, and environmental sustainability. His contributions are highly recognized with more than 130 research publications, thousands of citations, patents, books, and book chapters to his credit. He has been recognized among the world's top 2% scientists by Stanford University rankings for several consecutive years, which clearly reflects the global impact of his research. Dr. Sathe has also received several prestigious awards, including the Fulbright Fellowship, Young Scientist Award, and honors from the Maharashtra Academy of Sciences. He has delivered over 100 invited lectures at national and international platforms and continues to inspire students and researchers through his academic excellence. Dr. Sathe's journey truly reflects dedication to science, innovation, and education, and we are extremely fortunate to have him with us today. On behalf of the organizing committee, I warmly welcome Dr. Bhaskar Sathe sir and look forward to his valuable insights. Thank you, sir. Over to you, sir.
Thank you, madam, for a nice introduction. Of course, nice words. As just 1 minute, I'm not able to share. Hope the slides are visible. Am I audible?
Yes, sir.
Okay. Good afternoon, you all. Thank you, madam, for a nice introduction. As a part of today's this STC on renewable energy applications for green economics, organized by UGC Malviya Mission Teacher Training Center, along with the HRDC Center of University. I would like to thank organizer, director of this center, Mahajan Madam, my friend Rafi sir, and the coordinator for this workshop, this short trainings program, uh, Professor and Head, Department of Physics, Pravina Madam, for inviting me as a speaker for this session. Right. What I'm going to talk in next 1.5 hours is how the novel materials are coming up, how to build up this such type of materials, and utility of this material towards the energy economy, because energy as one of the uh, important part of developed countries, right? So as a part of that, as Madam said, my journey started with the same university from the Dr. Babasaheb Ambedkar Marathon University. I am a student in 2001 to 3. Then I got an opportunity to work for my PhD in National Chemical Laboratory, is one of the premium institute in Maharashtra, located in Pune. I was there for 2004 to 11. Meanwhile, I got an opportunity to be a part of this university as an assistant professor in 2008 onwards, followed by associate, and now I am a professor since last 2 years. Meanwhile, I got an opportunity to work as a Fulbright fellow for my higher studies, that is postdoc studies in USA, New Jersey, through this prestigious fellowship. The work which I have done in these three institutes that reflects actual my expertise in development of materials for energy application, especially the renewables, development of renewables. So the outline includes the how the physics, chemistry, and engineering of materials takes place together. Why do we go for the new materials? What is the science behind this? How to go for the optimization of material as per the need of the utility of this material for a certain applications. In role of the nanotechnology, their key challenges, followed by the impact of work based on the its societal utility. Right. Finally, I will conclude my talk with some of the questions further I will put for you. Right. So, as the new field is coming or the new materials are coming, especially people are working on the optimization of the nanomaterials at the nanoscale. Hello, hello, number 14. So I was talking about the materials, nanomaterials, and it's actually the importance over the materials, right? So in that sense, if you go toward the lower possible dimensions, the material will change their science. It means if it is a solid, it will be in a liquid form at a lower dimension. If it is having a certain color and a normal condition, it will change its color at the sense. Its skin will be more active if you go toward the lower dimension. As like the example of cement, I will let you know. The cement is the powder which is made from the stone. Stone is having the different role than the cement. Cement will be more active compared to the stone, right? So it means what? If you go toward the lower dimension, the material changes its properties, and that properties utility is will give certain solutions or the some answers of unsolved problems which society is facing these days, right? In this line, Richard Smalley and Richard Fleman together have contributed a lot. Because of these people only this science word has changed to the nanoscience, and the technology word has changed to the nanotechnology, and huge change which we are observing in the industrialization or the to improvement in societal what lifestyle we can say. In this line, the Richard Smalley he put the word in his talk. Nanotechnology holds the answer to the extent there are answered the most of the pressing materials needs in energy, health, communication, transportation, food, water is indicates yes the new material which is coming in the market will resolve certain issues, and he got a Nobel Prize on the discovery of this small fundamental unit of carbon which belongs to the controlled number of carbon number, and this is a C60 number of carbon comes together will become a ball. This ball is in having the dimension in the nano, and we can see that is under the microscope, right? So this allotropic form of carbon is developed by the Richard Smalley. Just 1 minute, I don't know how high is not moving. Right? Okay. Sorry for there was have some technical problem was there. So once upon a time, the story was different. People used to be consider big things are good, and that becomes a tourist places and all these things. You take an example of the safety wall of China that is having the length around 6,700 kilometer. Pyramid was the another example, having the height and dimension. If you're talking about, it looks what you can say the crazy for the peoples to be, and that the reason why it becomes a tourist place, right? So, but the scenario has changed. Now we reach to the see the even single atom how it behaves, right? In present time, the smaller becomes better. In that line, solid state electronics is growing like anything. That's the reason why we are observing the prices of electronic equipments are coming down day by day, right? So it means there are the instrument there are the certain instruments where we can see under that microscope even single atom how it is settled and how it is behaving, how it is reacting with the neighbors and all these things under microscopic conditions, right? So that is the reason why we can organize systematically single atoms, and we can allow the single atoms to transfer the electron very systematic and controlled manner. That is the actual the beauty of this today's semiconducting electronics, right? So where the credit goes to the development of new techniques in instrumentation, right? So if you're talking about the length scale, I will spend some time on this. If the atom, if you're talking about its dimensions are below 1 nanometer, if the moderate atom, if you are talking about whose dimensions like a gold or transition metal, any transition metal, right? So few atoms comes together will become molecules having the little complex structure, and that complexity will be increases if you are doing allowing the number of atoms to come together. But at the end, the dimensions are growing from the angstrom to the nano, nano to the micro, micro to the centimeter and inch, like different length scale, molecular length scale we are representing here with. But the complexity will increase. If you want to go toward the lower and lower independent atoms identity, we can represent independently, and that's the actually the case where these days researchers are doing. Right. As I was talking about, the Richard Fleming is the another contributor who talked in his meeting in 1959 in a annual meeting of APS at Calicut. So he talked, there is a plenty of rooms at the bottom. It says at a small nanoscale, the fundamental unit is the atom, and atom will be the foundation for the any material. Right. So then what is the role of chemistry here? As a chemist, I can say we should have the always curiosity towards the development of a new material. If you are adding one more atom to the any reactant, there is a new material formation, and that new material is having the different structure, different properties, and that different properties will utilize for a certain application. That is nothing but a utility. It makes it stand. John Baldwin's word is that the chemistry is about making a different forms of a material that have never existing before, and that stand on two legs. That is, one is the curiosity and another utility. These two things is responsible for the development. So what happens if you go for the controlled size of the nanomaterials? It's a physical and even the chemical property changes. Physical property in the sense what? If you have the lower dimension, see the radius which is around 1 to 1.5, the melting point decreases. This is an example of a gold, where the gold will be in a melting form, in a colloidal dispersion form at a lower dimension than like a 2 to 3 nanometer. It looks like a clear solution. So that never expect in a melting condition. Yes, okay, 1500 degrees centigrade temperature, if you apply, it will get melt. But that is not a case. At a room temperature, you observe the nanoparticles are in a dispersed nature, right? And is having a different color. How it is there, that we will see. But in addition to that, the electronic properties also will get changed. With the diameter, it is having like an insulator at the low dimension, which is below 1 nanometer, and till 6 nanometer, it looks like a size dependent electronic structure, like a band structure, right? This is the case again for the metals, like highly conducting metals, right? So melting point, band structure, along with the electron transfer, it semi-conducting band gap engineering is nothing but a number of atoms decides the band structure, right? So by this way, and so earlier the story was different. We are not able to make the smaller wire. So the bigger wire was there. If you want few electrons to transfer, instead of that, electrons are drained more than 500 together, like 1000 together. So the battery will get go off before the estimated time. So this was the problem earlier. So the problem has resolved by making a smaller wire, where if you want 2 to 3 electrons to transfer, yes, we can make an atom, single atom, like 2-3 atoms together wire, right? So by this way, the electronic properties also has changed. This is shown from this circuit, this cartoon actually over here. So if you are talking about the optical property, yes, optical properties has entirely changed. You will not believe this. The glass which I am showing is not of a wine. This is the solution of a gold nanoparticle. In 1857, Michael Faraday accidentally observed, yes, if you have the colloidal particle having a different size, is having a different color. Accidentally, he made the different concentration of the gold. He added the organic molecule as a functional molecule, as a tartaric acid, and he wait for some time. He went for a tea and come back, and he observed, because of the different concentration of the Au3 plus ions, he observed the different colors for that solution. So the concentration decides the color is no, because of the availability of the atoms after reduction nearby, the cluster size is bigger where the concentration of Au3 plus is more. So likewise, he observed three shade of the colors. Some are the pink color, some is the wine red color, some are yellow color, some other case is the purple color, pink color. So there are the shade of the colors. And once he observed under microscope, under UV visible spectra, so he got a different observables for this. What it indicates? The size dependent optical properties of this gold nanoparticle. Of course, under microscope and under spectroscope, we have the different information. Under microscope, if you observe, under microscope, you will get a different size for these particles. Under spectroscopy, different observers for this. And from where it comes, for once the few atoms comes together, will become a molecules or the cluster, and that cluster is having the hybrid electrons. That hybrid electrons are on the surface. Once such type of hybrid particle or such type of cluster, if it is exposed with the electromagnetic radiation, so the ionic cluster and electronic cluster, these two parts start separate out. It means that creates a dipole, and that dipole is proportional to the size. Right? It means the wavelength, if the sufficient for to interact with that dipole, means the that responsible for to push electronic cluster away from the positive. That result into the absorbance. Absorption followed by emission. If you observe, we have the complementary color for this, right? And this is because of the, and if the smaller the size requires more energy, and more energy shows the different signal than the smaller particles, right? So this is the case actually, and this frequency is directly proportional to the size, is also proportional to the shape in the sense, if it is a wire or is a tube, is having two dimensions. One is the along the length and another is the along the width. So there are two different absorbers in that case. We'll get a solution. We're having the mixed color. Two colors we have mixed together, like that shade you will observe. But in you under the UV visible, you will get two different independent signals. Right? So this is the case actually, which will be related to the optical properties of material. Another one is the energy diagram. If you are talking about the particles, intermediate and molecular and bulk solids. So if you are talking about the smaller particle like a diatoms together, two atoms comes together, their atomic orbital overlap result into the molecular orbital formation. And this molecular orbital formation, where the one will go down, one will be up, like we used to say is the HOMO and LUMO. Highest occupied molecular orbital will be lower position, lowest unoccupied molecular orbital will be away from, is like at the highest position, right? So if you are keep on adding the atoms, so this molecule will shift into the cluster, but the atomic orbitals are increased, so the number of molecular orbital increase, and of course the electrons involvement will be more, so the Fermi level will shift toward the higher position from here to here, and you will observe this gap is becomes down. So this gap will be the control gap. Here, if it is an insulator, this will be like a semiconductor, and this will be like a metal. If you don't have the control on the atoms, it will go toward the metal formation, right? Like a metal. So this what it indicates? It indicates the number of atoms decide the band structure, right? If you have the smaller particle, it looks like an insulator, even though the metal atoms are of highly conducting material like copper or the gold or the aluminum, whatever may be, right? So by this way, we have the self assembly of the number of atoms or the molecules together creates discrete energy levels, and that represent their atomic orbitals, right? And that will shift into the bands, right? So the bunch of molecular orbitals at the down as an HOMO will represent the valence band, and bunch of highest means like LUMO, bunch of orbitals corresponding to the LUMO will consider will become a conduction band, right? So by this way we have the energy diagram for the nanoparticles. This is an example of that. I don't want to spend more time for this, but yes, this is the proper judgment which we have shown here, corresponding to the number of atoms of a gold and their band structure, right? So if you cross the limit of AU more than 300 count, it will work as like a bulb. It means you should have the control which is below, right? So this is like a molecule like band structure. And of course, generally the most of the chemists and physicists are looking for nanoparticles in this point of view. One is the how to improve their scheme. We used to say that is a surface area and surface to volume ratio, I can say. So what happens if you made the smaller particles? Consider an example of again the stone to cement, or from the gehu or jawar to the atta, whatever may be. What we are doing, we are giving the exposure to the material which is inside and which is shielded by the skin. What we are doing, we are breaking in such a way that the atoms should come on the surface. Smaller the particle, like a 3 nanometer, around 50% atoms you will observe on the surface, right? And if you go toward the higher dimension, like instead of 3 nanometer with a 10 nanometer, the count will come down, because some atoms there will not be the exposure. Similarly, if you are talking about the 30 nanometer particle, if you 10 times size, if you increase, 10 times presence of the atoms on the surface will get decreased. For the 30 nanometer, on a skin, very less amount of atoms are there compared to the total atom. Right? It means ultimately, if you want to allow the surface to do some surface reactions, so we need to allow that atoms to come outside. That's the reason why people are talking about the porous material, people are talking about the smaller nanoparticle, people are talking about the decoration of the nanoparticle on a substrate, and so on. Or making a cluster or by the organometallic compounds, just to make the cage and allow that atoms to be behave independently, like a hemoglobin molecule, like a chlorophyll pigment molecule, such type of molecules, where the atoms are at the center. Right? So this is the case actually. Materials are developed. So then electronic as like a electronic property, as like a optical property, as like a surface catalytic property, electrode potential also will get vary, depends on the dimension. Right? As we know, one of the element will show the electron transfer at this one, but that is a bulk. The data which the science which we learned from the inorganic, either we or the Atkin or the J.D. Lee books, that is totally for the bulk material, right? But here what we are seeing, or with what we are talking about, the beyond the material which is existing or the visible for our eyes, that is the nanomaterials. And nanomaterials are having the dimension in a nano size, in a nano, and we can reach, our eye level is up to the micron, right? Beyond that means like a 10 raised to power 6 times smaller objects we are observing, right? So this is the case. Then question comes, how to make it. Very simple approach is the bottom up approach, where people are talking about the take an atom together, allow them to interact, make a molecule, and that molecule will further will go for a certain application. Control molecules means like if you have the control on the atom, yes, of course, we have the more utility of that because of the exposure. If you are able to make the independent molecules, yes, of course, they have the, but the chemistry is involved in this bottom up approach. Top down, where the more is the physics, the mechanical methods are there. So where the powder can make it, but powder unfortunately are not all particles are having the same size. Depends on the process which we are using and all this. But here, in case of the bottom up, yes, everything is under control. If you have stopped the temperature, nothing will happen. If you stop the potential, nothing will happen further. Right. So this is the case actually talking about the bottom up. So this is the case, or these are the existing methods which are associated with the bottom up approach, that is chemical vapor, electrochemical, that may be the electro deposition, that may be the galvanic method, where the self assembly of atoms or the molecules together will become a nanostructures. Nanostructures, we can make it from the macromolecules. Right? This is the case. Actually, the people are talking about the fabrication of nanostructures. Then these materials which we are going to develop, or which are people are developing by these two approaches, can use for resolve certain challenges which humanity are facing globally. I am talking about for the next 15 years. So where we are, how the sequences got changed. As we know, our basic, what you can say, the challenge of a common people of the India was the Anna Vastra Nivara earlier, right? But that has changed. We are in a line of developing countries, and we are going to become a developed countries in during the celebration of, or we have the target of to become a developed country in 2047. Accordingly, we have the n number of policies. Government is started working on that. The Atmanirbhar Bharat, Make in India, Made in India, right? So this in all fields are growing, right? But this comes from how we are giving a solution for the global challenges, right? Because we are in a developing line of developing countries, so of course we have the questions very close to us. Which questions? Those questions are global. It means if you are coming in a competition globally, of course, the global problem becomes a local problem, right? And these days are to become a local from a global is very easy because of the easy transportation, easy industrialization, easy communication, networking is very fast, and all these things, right? So then the sequence has changed, and energy becomes one of the biggest challenge which common people are facing. Then the quality water, because energy is again close to the environment, and especially if you are talking about the India as a model, yes, we are totally depends on neighbors for the energy resources. Petrol, diesel, or the gasoline resources, we are buying from the neighbors, right? And as energy is the topmost challenge globally, the country, those who are having their independency in this energy, they will run the hold on all countries. In that point of view, as usually all of you know, the United States is having the global hold. They decide. India has to fight with the China, or India has to fight with the Pakistan. They decide. They will they decide on which side they should put up with their weight accordingly, right? So it means, yes, of course, the energy become a biggest challenge, because everything is depends on the energy. Transportation, industrialization, communication, or a common lifestyle of the every people, where the energy is very important part. And second one is the quality water. Even though the globally we are talking about, water is having around 80%, surface is covered by the water. 20%, yes, human people are live, means like people are living on the earth surface. So the quality water is the biggest issue because of a number of reasons. Every family we are observing the RO system is there, right? Quality food, because of the certain unmanageable things, food is not quality. And these three challenges are very closely associated with the environment. Environment, clean environment is the again biggest challenge which we have, right? So the if you are talking about the food, now as we know, the we are facing a very big problem with the quality food in cities, and because of the industrialization, overutilization of the fuel, we have the problem with the environment also. We are not able to recover, and other problems are secondary problems, but yes, there are problems, right? So by considering these are the challenges, our government is taking a steps, and of course in 2047, where we are going to complete 100 years of independence, we have a different India. We are looking India in a different point of view. In that case, in the research, government is trying to give the possible infrastructures to the people, those who can work here instead of going abroad, right? So in that point of view, yes, we are in a right track, but overutilization of fuel result into the burning of a galaxy at both end, and we are observing somehow the ice is started melting, and this melted ice where the water is getting converted into sorry, ice is getting converted into the water, and sea level is going up. This is unfortunate at one side. Other side, because of this temperature, why, from where the temperature comes? The temperature comes from the overheating of the earth's surface, where the carbon dioxide gas is responsible. That carbon dioxide is the output of the product of the burning of the hydrocarbons, and you observe these hydrocarbons are responsible for this, and result into the engagement of this radiation which are coming from the sunlight to make them engage on the surface, and you will observe the radiations are settling on the surface by converting the light into the heat, right? And this is the case actually where the this particular heat energy, or the surface is getting hot, and the dry areas like Marathwada becomes dry, and the sea level again evaporation is there, and result into the accidental rains you observe during the, because see what happens if the temperature goes up, water start evaporating. If on just imagine on the earth sea level, the water evaporation rate will be high compared to the normal one. And then water is in a vapor phase is more, creates the pressure, and because of the pressure, that whole vapors of water will shift to the from the sea level to the surface level. So where they will get cooled, and as a result, sudden there will be like a heavy rain like Dagputi that we observed during the last 4 5 years ago. That was the China, this Chennai flood. Mumbai last year's rain, just you observed it. Tamil Nadu, some places, Kerala. These are the heavy rains which we observed because of only and only the CO2 emission. So that creates, this is again is having the connection with the unmanageable things at the cities. In India, this is a major problem where the people are moving from the villages to the cities. There may be a number of regions. Some people are thinking about, yes, we can at least for the next generation will give the better life, right? But quality food, quality air, quality water, we are not getting in a city. right? And for government is also it's unmanageable. Just see the population wise, the mega cities where the India is leading. India is on the highest position, where the number of highly populated, we used to say the mega cities are more, right? And now the cities are increasing. 10 years back, today's Mumbai, today's Pune is was like Mumbai. Means to at that times 10 years back, Mumbai was like today's Pune. It means every 10 years, 10-15 cities are getting converted into the normal city to the mega cities, right? And so because of that, it becomes unmanageable. And as an India, we are in a pollution quality index where you can noted as a red zone instead of a green zone. See the places, beautiful places around Russia, around America, different places if you observe, or some this side also, Osaka, Japan, some places, somewhere in Korea, it is Australia. These are the places where we see they have well maintained everything as far as the pollution, population, everything is well maintained. But unfortunately, we don't have the India, we are suffering from this among the all countries, developed countries, where they are managing so quality of air, quality of food, quality of water, drinking water, and all these things, right? Yes, then question comes: is it really there is no alternative for the fossil fuel? Yes, there is an alternative. Nuclear power is the powerful source of energy, and we can say it's a renewable source. Reason why it is highly manageable and is having the zero pollution, right? And this is the structure actually where the globally people are using the nuclear power as the source of energy. France around 76%, Belgium around 56%, like United States and India is around 17%. We are using uh, over the total energy, the nuclear energy from the nuclear power, right? So but the problem with this is, if we are not able to maintain uh, shielding, or it's not controlled, it will be like a nuclear pollution. The example of a 2011 crisis at the Fukushima, this was the big disaster where we observed that this particular during the earthquake, the power was cut, and because of the power cut, they are not able to manage or the maintain the cooling system, and hold reactor blast because of the overheating inside, because nuclear reactions there is no control, right? So we need to maintain only the emitted heat to control it, right? So this way if we have the control system, yes, we can go for the nuclear power is the powerful source of energy. Yes, another renewables are there, right? Over this, that is wind energy, solar energy, oceanic energy, hydropower energy, geothermal, biomass. Unfortunately, this is not sufficient. We have the end users which are using for them this is very less amount, and everything is on the energy, right? So then the question comes: is time to move from, or we are at the highest position where we need to think about some other alternative for this, right? Energy is one of the grand challenge of our time. Energy is not a monolithic issue. Yes, depends on supply. It depends on the demand of the people, its conservation, its application, scale up, its location, its independence, environment, climate change, GDP variation, carbon intensity, infrastructure available, technology, transport, or the policy implementation, sustainability, and public acceptance, right? So even though these are the resources, these are the problems associated with them, right? But well settled fossil fuels will be important throughout this country, But unfortunately, we have the n number of environmental problems like a carbon dioxide emission and carbon dioxide. If you're talking about carbon dioxide is having two issues. One is the global warming is the one of the major issue. And second one is we used to say the carbon dioxide is not a pollution because as such it's not a corrosive gas as like a SO2 or NO2. It's not like that. But carbon dioxide is a highly stable molecule. But unfortunately, what carbon dioxide does, every molecule is having the attraction toward the Earth's surface based on the gravitational force. Right? So the gravitational force which is acting on the molecule, right? M into G, M stands for the mass of the carbon and two oxygens together, where the carbon dioxide stand on the from the surface on a like a 5 to 7 feet from this. So what happens to this then? So then what every molecules of a carbon dioxide which is coming from the surface or which is coming from the chimney of the gas of the industry, everything will come in that zone and that displaces the oxygen molecule from that zone. So it means this is the zone which will cover the maximum noses of the people. Means the height of the people is in this zone, like a 5 to 7 uh, feet, right? So this is the case is responsible to convert the car to declare as a carbon dioxide is also one of the pollutant, where higher the concentration of this, like a 70-80% carbon dioxide is coming in this zone. The on a places like a Gulmandi or the places like a bus stop or places like a railway station or places like a whole Jalna road if you are talking about in Aurangabad. So at these metro places in a city where the carbon dioxide limit is more than 70%. And in everything is coming and settling in this zone means the oxygen level is less in that zone. You will comfort, your comfort will get loose. You will feel uncomfort. Your kids are started crying in this once they are there. Senior citizen will feel uncomfortable. So this is the problem. So then better it is the time now to work on the carbon dioxide, not to go for a higher level. So the fossil fuels to some other resources we need to shift. Then the renewables are growing rapidly, but their base is very less. Each barrel of the oil saved keeps $1 in our pockets and near about 1,000 pounds of carbon dioxide out of the atmosphere. But we can't save our way to meeting the world's future energy needs. This is the fact, actually. Right? So then if you want to avoid carbon dioxide, better to go for the hydrogen. Hydrogen is the element in a periodic table which gives huge energy. That is hydrogen, like a 38 kilowatt hour per kg, this much energy this supplies. And these are the other resources of the, where if you are comparing this with this, the huge response will come from the hydrogen, or the existing one is the methanol is flexible, that is 6 kilowatt hour per kg, that is for the petrol diesel. Compare these two, where is the figure? And another beauty is that hydrogen stores approximately 2.6 times more energy per unit mass of a gasoline, and leading to the zero emission of the carbon dioxide in the environment. Because of that, there is no issue of the the global warming, and there is no issue of oxygen displacement, right? And this hydrogen we can use as a fuel in the fuel cell. We can supply this hydrogen on one electrode, it will get split into the H plus from one side, another side from the air the oxygen comes, oxygen will get reduced into the OH minus, H plus from one side, OH minus from another side will become the H2O molecule, and this molecule greener one, there is no harm, and by the cost of that electron transfer result into the conversion of fuel plus oxygen into electricity plus heat, right? This is the case. And once that electricity is generated from this cell, This we can use for the transportation, building, industrialization, maybe for n number of internal approaches where the hydrogen become a primary energy source. Right? Then question comes from where the hydrogen is coming. Yes, then generally if you are seeing the resources of hydrogen, the 48% people are collecting this from the natural gases, 30% hydrogen is collected from the oil, 18% it is from a coal, and only 4% from the electrolysis of water. Why I have given the different color for this is the reason why we have the natural abundance of water is 80%. And that we can use because each molecule of water will give us one molecule of hydrogen. And likewise, another side product is the oxygen. If you want to collect the hydrogen from the water, we have the oxygen at the another side. Then question comes how to make it. We have a source of energy as an electricity. This we can where we can connect this to the water. So the water start breaking. H plus and OH minus are there herein. The H plus will go toward the negatively charged electrode like a cathode, and you will observe the H plus is getting converted into the H2, and the H2 will be coming out as a gaseous hydrogen that we can fill in the cylinder, and we can transfer it some other place for as per the need of this one. Another side, yes, there is a very big partition based on the charges. There is ion separation, H plus, where you will not absorb any oxygen molecule, and from the oxygen side or for the anode side, OH minus are running where the molecular oxygen will get formed. And that molecular oxygen we can store in a cylinder and we can use for the medical purposes or some industry purposes, whatever may be there, right? So this is the case where the water electrolysis happens. This is the chemical reactions. H2O, where the oxygen is there, we'll have the 2H minus result into the O2 oxygen, and it's a 4 electron system, where if you are keep on increasing the positive potential, one potential comes at which it start getting an increase in the current that represents the OH minus is getting converted to the oxygen. And these 4 electrons are coming. These 4 electrons are responsible for increasing the current. Another side is the cathodic reaction, that of course the current will be the negative current and that will come down. If you increase the potential, yes, it will go down and down and down, more the line down, that represent more the cathodic current, more the hydrogen generation. So likewise, we have the hydrogen generation over here. It belongs to 2H plus 2 electron, which is coming from the electrode, and there is a formation of hydrogen. This is the case. And this represents the foundation of the hydrogen economy or hydrogen resources or the hydrogen source of the energy instead of the fossil fuel. And these days, people are started working on this extensively. There are hydrogen plants. We used to say the green hydrogen, the hydrogen we are collecting from the water, that is the green hydrogen. The hydrogen which we are collecting from the hydrocarbons that may have some impurities that need some processing, so that belongs to the gray or blue. There are different shades. The shades are given or the marks are given based on the source of hydrogen. Right here at the end, nothing will be missed. Like if you are collecting the hydrogen, if you are concentrating on the hydrogen, yes, other side will be oxygen. See, unfortunately, electrochemical system where we need to work on the both reactions. If this cathode is not supporting, anode will not work properly. Anodic reaction, if it is not supporting, so cathodic reaction will not work properly. Right? We need both simultaneously. So in that case, people are working on a development of the new material which work for the hydrogen production, or if you want, even though if you are not able to make the good system for the hydrogen production, work on the good system for the oxygen production. Of course, automatically another counter reaction will be hydrogen. We can collect that hydrogen somehow, right, as a source of energy. right? So by this way, or some people are working on both bifunctional electrocatalytic system, we can say. So where the electrocatalysis, which supports good for the hydrogen production, is supports for good for the oxygen production. Likewise, right? So if this is the case, but especially if you are talking about any electrochemical system, that is the interface of the liquid solid. And liquid solid interface at an applied potential is not stable for a longer time. That's the reason why, because of the batteries, we need to throw the either laptop or the mobile sometime. The reason why the battery is not supporting properly. At the age of the one laptop or the age of the one mobile, we need two batteries. At the mid of the life of an electronic circuit, we need to change the battery once. Especially this is more uh, recognizable for the more laptops that we know, right? And so if the materials are stable, yes, there are some materials, they are stable at this such type of interface. I am talking about the any electrochemical system. That may be the fuel cell, that may be the battery, that may be supercapacitor, or that may be the assembly of the hydrogen production, right? So materials are expensive. That's the reason why this is commercialization is locked. Now we are observing some people, some charging, what you can say, the charging based vehicles are coming, right? Battery based vehicles are coming. Some hydrogen based vehicles are there abroad, somewhere in the developed countries, because their safety rules are good. They can fill hydrogen like a diesel petrol. If you are filling that hydrogen as a fuel, like we are filling a vehicle with the hydrogen bombs, and this is not safer. Here we don't have the that much. We have not taken that much responsibility as a to follow the rules and regulation of the roads. Roads are not in a quality manner. The roads are not quality roads, right? So these security issues are there. Because of that, hydrogen based fuel as an fuel commercialization is locked. And another challenge is that its material becomes expensive. If you want to check the stable material, platinum, gold are the stable, but they are expensive. Electrode degradation is the another issue. Reason why the if you want these expensive material, if you have used, somehow at their surface will get infected, becomes oxide, will not allow that atoms to show the further electron transfer, and because of that, the whole performance of the battery comes down. We cannot expect the day first it work for 2 days. We cannot expect the 2 day charging support from that same battery after a year. This why this is coming? Because the electrode interface is not active that much. Uncertainty in lifetime, it's high ohmic losses. Sometimes the electrolyte will get decomposed, and the overall the conduction of the ions will come down. That becomes a high ohmic loss. Sometimes surface will become one layer of the oxide, and so that will not allow electrons to transfer. So the charging is not properly happening, and discharge will be very fast. So these are the problems. So then people are trying to make the material cheaper by connecting some other metals with the platinum. Some people are using carbon-based materials are coming up, graphene, carbon nanotube, C16, right? Some hybrids are coming. Some nowadays the superior like a single atom catalytic systems are coming. People are trying to work on that material to develop a new and new materials, and these new materials becomes actual the key for the improvement in a performance, right? In this line, my research work or my research group is working on this these problems. One may be the fuel cell development of the electrocatalytic system, which convert fuel into the electricity. That fuel may be the urea, that fuel may be the some other organic molecule, that may be the alcohol, that may be like a glycerol or some other molecules. Like, hey, this is one case. Another case, the water splitting reactions. Split the water in such a way that we can get the hydrogen, or we can use some other molecules other than the hydrogen to split. Ultimate aim is to collect the hydrogen, right? So that material may be like H2S, hydrogen from the sulfur, hydrogen sulfide. We can take it the hydrogen from the ammonia. We can take the hydrogen from the hydrogen, right? We can take the hydrogen from the like organic molecule. So that is the breaking of the molecule in such a way that we ultimate aim is to collect the hydrogen. This is one other area. Environmental remediation, where the like industrial waste, we can work on waste to the best. Some problems related to the this medical laboratories, where the waste we can convert into the waste, because that will affect more strongly on the biological life cycles, right? Where the environmental remediation type of work we are doing, we have the active group in conversion of carbon dioxide, because the carbon dioxide is coming from the vehicles after systematic burning of the hydrocarbons. But this carbon dioxide in environment creates the problem that we have talked about. So is it possible to convert this hydrocarbon to the this carbon dioxide to back to the hydrocarbon as a fuel? That we are doing. Actually, conversion of this to the formic acid, formaldehyde, methanol, methane, or if we are able to make the carbon-carbon bond formation, yes, we can go for the higher alcohols like ethanol, ethane, right? Acetaldehyde, acetic acid, such type of things. So this is also one of the activity which is it possible to utilize this carbon dioxide to develop some of the organic molecules? That is known as the utility of this carbon dioxide. Environmental electricity belongs to the carbon dioxide. So some energy and waste management, that also we can do, like a nitrate conversion, artificial nitrogen cycle, conversion of nitrogen to the ammonia, and this ammonia plus carbon dioxide, if you make together, will get the urea. So urea synthesis is also one of the target we have, right? So this way, this is the actual the overview of the activities which are going on in my lab, right? As a part of environmental electrochemistry, carbon dioxide reduction and its utility, we have developed an electrocatalytic system which is cheaper one. We have started with the carbon nanostructure. Carbon nanostructure we have modified with some metal. We made the hybrid. We can make the defective centers, where that defects where the carbon becomes around the whatever the carbons are there. Carbon we have made it more active. To improve its activity further, what we have done, we have loaded this systematically, substitutionally with some other metals, and these are the like doped graphene. So such type of materials we have used an electrocatalytic system for the conversion of carbon dioxide into this value added products. Further, if you work on this, we'll get the hydrocarbons. And these hydrocarbons we can use for a certain application. These are the analysis. For this, we can analyze the product by high performance liquid chromatography, FTIR, or the mass spectroscopy. So that will give the idea. Of course, the CO2 is having the problem. This is potential dependent products will get it. We'll get formic acid, we'll get a formaldehyde, we'll get the methanol, we get the methane, we'll get the radical of this, we get the mixture of the carbon monoxide and H2O. So, right, CO2 reduction is having the variety of products. Sometimes mixed product will come, sometimes selectively one of the product will come, right? So, pathways for the reduction is like this: CO2 will come, adsorb on the surface. To make the active sites on the surface, there are the ways. So, these ways we can apply. So, here this adsorption followed by its polarization. If the polarization is there, the proton will come from the solution, will attack on the carbon, will become a CH. This is the rate determining step actually to get the electron withdrawing and addition of the H plus, right? So likewise, Same thing will be there, electron and proton transfer result into the format formation on the surface. So once that becomes a format, it will leave the surface. So the sites will be further available for the another CO2 molecules to interact with this. This is the case actually where the CO2 reduction, in case of the CO2 reduction will work. Another case is the CO2 utilization. We have the electrocatalytic system which we have developed on a carbon by the some hybrid nanoparticles. So the carbon dioxide from environment will come, adsorb on the surface, followed by electron transfer, because that electron transfer is in our hand, which we are doing. Either you are making it the anode or the cathode, that decides the electron deficient or the electron rich sites to make on the surface. So accordingly, CO2 will get converted into the CO, will be the active species. The CO along with the ammonia, if you insert, so this becomes CO and both sides ammonia, that is a formation of urea. So for that, either you can go for the NO3 pathway, adsorption, stabilization, followed by the product formation, right? So this is the way actually the environmental electrochemistry works: CO2 reduction and utilization for in case of the electrocatalysis, right? So these are the different systems we are showing here. The zinc oxide gallium nitride based the system we have used for formation of formic acid here. We have the graphitic carbon nitride, which is decorated by manganese oxide. And so this system we have used for the this formation of the formic acid. So this is another system which is there. So third system here, the bismuth oxide decorated on the reduced graphene oxide. We have used this method for the conversion of carbon dioxide into formic acid. There are some other systems like a palladium copper bimetallic system. We have decorated on the reduced graphene oxide. So this we have used for the CO. I am just a representative schemes I am showing. Actually, the data for this is there, but is of no use at this point. But I'm giving the exposure, or I'm exploring the materials which we have used, right? In one case, we have used alumina decorated on the reduced graphene oxide, that is used for this one, right? Conversion of CO2 to methanol. Another case which I was talking about, the water splitting reactions, and target is to generate the hydrogen, right? So here, as we have shown, we are talking about this zone here, production of hydrogen from this. Very first reaction is either you take the carbon nanotubes, treat it with the acid mixture, we create the oxidized functional group on the surface, means some of the carbon sites will get oxidized and will get a COO minus, SO3 minus, such type of moieties on the surface. And if you treat this with a dilute HCl, we have the further protonation. If you have added any metal salt, what will happen? This M plus will go and settle on that surface, because that will displace the H plus. The reason why, as far as the concept of Lowry-Brown state as concerned, conjugate acids will get formed, right? And result into the further, if you have given the reduction steps, this M plus will get adsorbed on their active sites like this, right? And you will observe this is decorated on the surface. Similarly, you have the another electrocatalytic system where the graphite functionalized, reduced surface, made the defective graphene. Further, you have reflux in a THF borane, in a THF solution, where you will observe this boron is systematically entered into the zone. And there is boron substituted graphene we have form. And this center will become an electron depletion center, will collect the electrons from the backside and will show the electron transfer herein. So H plus electron will get the 2H plus comes together plus 2 electron from this side will get the molecular hydrogen. And this hydrogen will be the source of energy for us. Right? This is one case. Another case is like H plus will come Arsor on the surface. Another H plus will approach, right? And this another H plus will give the molecular hydrogen. One step H plus will absorb here, another H plus will absorb here. They will combine together and will become the molecular. These both steps can be possible in case of this hydrogen production site. Another case is develop the phosphorus decorated sites on the surface of graphene, and that we have used for the oxygen generation from the water. Same way, see this mechanism here. OH minus from solution will come and absorb. Another OH comes and you will take the H plus and electron transfer will be there, will become a O minus. Another water molecule interact with this O minus, result into the peroxide formation here. And this peroxide further interact with the OH minus and result into the conversion of this oxygen on the surface, and this oxygen will leave the surface in the molecular form. Likewise, this is the mechanism for this. Right? Another system where the rhodium nanoparticle we have decorated on the graphene and we have used this for both. This is the bimetallic system where the oxygen generation is also possible in a good way, and similarly the hydrogen production is also possible on the other side. So the hydrogen evolution reaction one side and oxygen evolution reaction on the other side. This is the case where the water splitting happens on the rhodium nanosphere decorated on the graphene oxide, right? So this is the case where the bimetallic nature. Another case where the amino acid we have decorated on the graphene oxide, that is lysine and functionalized graphene oxide, and this system is good for the OH minus to absorb on the surface, result into formation of molecular hydrogen on the surface, right? And we will see the oxygen is getting out. There are some other systems, molybdenum oxide based graphene oxide, where the same hydrogen production we observed in this. Right? So hydrogen rich species to hydrogen. This also can do. So here we have developed the nickel oxide nitrogen doped system, carbon nitride system, and this material we have used for the electrocatalytic isopropanol oxidation to the isopropanol to acetone, and we observe the hydrogen is getting formed here. Right? Similarly, another system where the H2S conversion, another system where the hydrogen to nitrogen conversion. Hello. In another case, the hydrogen to hydrogen. These are the cases where the hydrogen as a fuel we can produce, is the one of the renewable source, I can say. So another work where this synthesized or this generated hydrogen we can use for to generate the electricity from this. So as having the limitations, its material is expensive, electron degradation is the problem, uncertainty in its lifetime, right? So but if you go toward the reduce the dimension, we can achieve the goal of production of electricity from the hydrogen as a fuel, right? So the hydrogen transportation is the problem, and the hydrocarbon, if you are using carbon monoxide and oxygen type of reactive intermediates will come, and that will irreversibly block the active sites, and unfortunately we cannot use this for further, right? So these are the problems. So then people are doing making the bimetallic system. One is good for the carbon monoxide absorption. Neighboring atom, if you have systematically arranged the ruthenium, which is support for the OH, CO plus O will give the carbon dioxide will go out. So this is possible. But unfortunately, this arrangement is not possible. Systematically, another metal we cannot load with the same metal. So this is the problem which belongs to the dispersion. So efficient electrocatalytic system where the CO2 to methanol, formic acid, this possibility is there where the electrical energy will get converted into the chemical energy. This is the case actually where the people are working on the optimization of electrocatalytic system, which is good for the hydrogen production or the hydrogen utilization. So the urea has a fuel, people are using formic acid, methanol, ethanol, right? These are the atoms which we have given in our case that I am representing here. Just 1 minute. So this ascorbic acid to dehydrated form hydrogen production here. Urea on Fe nickel system where the hydrogen we can produce. So here the ammonia electrooxidation as a source of hydrogen. Direct fuel. These are the examples I am showing as a direct fuel we are using, and that is converting to the electricity, and that electrical energy we can use for as a source for. Instead of a natural source, we can use the source as a fuel. So it means these molecule based fuels we can use even in a vehicle to convert into electrical energy to run your vehicle. Right? These are the examples. Again, this is the urea electrooxidation. This is formaldehyde and urea oxidation where we can develop the bismuth bismuth on RGO, which further modified with the cobalt bismuth bimetallic system on the reduced graphene oxide, and this is good for this system, this conversion, right? So by this way, we have the different electrocatalytic system which give us the renewable source of the energy. Right? As we said, there are some examples where we work for the electrochemical waste management. This is also part of the environmental electrochemistry, and where either this NO2 to NO3 conversion, this is on the nanoporous carbon. In some cases, we have used the bismuth oxide decorated on the multi-walled carbon nanotube, which is modified on the glassy carbon electrode. This is for the nitrophenol conversion, right? And so this work is also published. Semi-carbazide is one of the industrial product and need to convert into the oxidized form. This we can do by the electrochemical on cobalt oxide nanoparticles, right? So in some cases, this cerium oxide nanoparticle we use for the conversion of H2S to the SO2. Right, this conversion also can do in a controlled manner, as you can say is a part of electrochemical sensing, or you can say is a electrochemical conversion also. In some cases, thiourea oxidation also we have done as a product is SO4 minus 1 is sulfate. In tyramine modified graphene oxide we use for the ascorbic acid to paranitrophenol conversion. And so this is also possible. In some cases, yes, we have used this oxidized form of carbon multi-walled carbon nanotubes for conversion of some these biomolecules or some industrial waste molecules to phenol based molecules to some other usable form, right? So this is the case where the zinc oxide nanoparticle we have used for the conversion of NO2 to NO3. This is improve the fertility of soil or the control the actually the NOx from the environment as the source of acid rain. So where we have worked on these systems also. In some cases, dye degradation is the target where we have used this resource of electrocatalytic system to convert this into the carbon dioxide, right? In one of the problem, just I am at the end of this my presentation, I will show you one good achievement of our group where what we have done for the society. This is a society scientific approach for the conservation of Bidri art. Bidri art is the handicraft. This is like the material of a show. So what people have done, people have decorated on the surface. This decoration is of some other metal, like maybe the platinum, maybe the gold, maybe the silver. People are made by the curving on the surface, right? But the back color, backside, the background is black color. So this black color background will come on the material like having a color like a steel, which is made by the zinc and copper alloy. Having a 95% zinc and 2 to 10% copper. So in that case, this black color will come from the surface passivation. So to do the surface passivation from the long, people use the raw material that is a bidri soil from the bidar port, which we have shown here. But unfortunately, what happens? This soil, if people are taking out, so this port will go out, right? And unfortunately, archaeology people have submitted their complaint to the government, and government put a ban. So by considering this is the issue, what they have done, they have opened a call to the DST, and through DST we got a funding to work on this to develop a artificial soil. Artificial soil to make the surface black in color. This is the design, and backside we have the black color, right? So that we have developed in our laboratory. By different combination, we observe what is there in that soil, and we got 2 copyrights on this as a patent. We developed a solution in laboratory, and we have this alternative which we got from them, right? So with this, I would like to conclude that yes, new materials are growing, and these grown materials are good for the solve the issues common people are facing. I have concentrated here on this today's talk is only on how it helps to resolve the energy issue, especially to develop renewable resources. Another part of renewable energy is the solar that we know. Solar government is giving the subsidy, and everywhere solar we are observing. Our target as to move toward the based on the policies government has decided that should reach to the 2023 the targeted value of this solar distribution, but now we reach at that level. So today's status of solar distribution to the farmer is expected, it was expected for 2030, but we have reached on 2025, right? This means we are running in a right direction, and lot many the issues has resolved, right? Where the nanomaterials are having the major role. Probably in the future, the size of these solar panels also will come down, and efficiency will be tremendous, right? This probably we are expecting this will come very soon. And nanomaterials, especially hybrid materials, can provide a superior functions to anode and cathode during the storage of energy and all these things. And this will be active components, right? Where the everything will come together. Of course, I would like to thank, without support from the active brain and without working hand and their working brains, nothing will come out. That I feel from my side. And so that's why I would like to thank all my collaborators and all my students who they have contributed. I have shown the work of my all past students, and current students are having the future work which is going on. Right? Thank you very much. Of course, this is with the not possible without support from the funding agencies. We got a funding from the DST. We have the funding from the university. We have the UGC funding. We have the DAE BRNS funding. We have the DST SERP funding. CSR project. We have the ministry project under the SRI. We have the international funding from the United States India Exchange Educational Foundation, that is USIF Fulbright funding. Thank you very much. I am expecting the questions from you. Question, please. Any questions? There is no question?
Hello, sir.
Yes, please.
Myself, Dr. Sanjay Shenmare. My question is the solar panel price and the electricity board will not cooperate properly because there are the policies day by day changing. Nowadays, I think day use and night use, the price, the जनरेटेड इलेक्ट्रिसिटी रिफंडेबल जो भी चार्जेस है वो सब इट मे बी मेकिंग कंफ्यूजन अबाउट न्यूली कस्टमर्स. So what will be the clear cut policy of
course, see, the people are working on that, and government will come out with the proper solution. See, if science point of view, if you are looking for this solar system as a source of energy or the renewable, so it's coming very beautiful. The reason why I am saying, if I am a customer of solar panel, I install the solar panel on my top, right? So
Okay.
whole family means whole that building will be under electricity which is coming from this, right? And at the end, if you have taken the vehicle, charging vehicle, so four-wheeler or even two-wheeler together or both, so of course the energy will be sufficient energy. These days, see that 10 years back solar panels efficiency and today's solar panels efficiency is entirely different. Is improved tremendously. Probably in next 5 years, new panels will come with having the more energy. So the problem or the gap of the now the electricity board consumption and their prices and their values and the gaps or the efficiency or the outcome which is coming from the solar panels will come down. So in that time, of course, this issue which you are we are presenting, that issue will not be there somehow, right? In that case, actually government is, see, at the end now today the solar panel is also having the problem. The cost is huge. The silicon 111 is expensive. Its fabrication of solar panel is expensive. Government is taking a responsibility of that. 70% subsidy they are giving to make you comfortable to take it, buy it. Because to make the common people affordable or to make it popularized, this is the right way to go for that. And that government is successfully doing. Right? Yes, there are issues with the electricity board, and probably they will resolve somehow.
I think, sir, there is also a need of upgradation of the panels. Also,
Yeah,
maybe
panel. What I am saying, actually, probably after 10 years, this panel will not be there. That panel will be more efficient. And of course, they may how the people are working on the alternative for the silicon. we will get the better material, which is cheaper material than the silicon. So the next generation solar will be more cheaper, more efficient. If the 1 or 2 hour exposure of the electromagnetic sunlight, that is also makes more contribution toward the even though the more electricity will get stored in the at the end. So that way, yes, development is going on.
Thank you, sir.
Yeah.
Got it.
Any other?
Yes, sir, I have a question.
Please.
On what extent can advanced materials engineering contribute to energy self-reliance and economic development?
In terms of
In terms of economic development.
yeah, economic development, if you're talking about now, it is on a stable mode, but probably in a future, yes, if we become independent, see, renewables are growing means our dependency will come down. Our dependency, if it is coming down, automatically the economy, our economy will get saved. Huge amount of energy, huge amount we are spending for to buy the energy from other, or the petrol, diesel from other, gasoline from other, because without that nothing will. See, the transportation, industrialization, right, or the lifestyle, life cycle. So everywhere the energy consumption is there, and unfortunately we have the dependency. These days, this wind energy, this solar energy, this hydrogen based energy production, the nuclear energies, so these are coming up, which is become an alternative for this existing energy setup. And so of course that will be sustainable and that will be independent. For that, we no need to, for solar we no need to be depend on others. We have our land, we can fix anywhere, we can convert it and we can use it. So by this way, now today's energy source, today we are getting electricity from here. Somewhere at a corner, we are working on this petrol, diesel, coal. From that, we are converting the electricity and we are distributing through the whole Maharashtra or whole India. Right? So these things will get changed. And of course, this will, once we are comfortable with this change, we will be in a better position as far as the economy has concerned. Okay?
Yes, sir, I understand. Yes, sir. Yes, sir.
Okay.
Thank
Thank
you,
you.
sir.
If you have any question, or if you want to collaborate in this line, this you might have got my the on which area I am working or I am comfortable. You can come at any time. We have the open lab for to work with me. Okay. Thank you. Thank you very much for patiently listening. Can we stop then?
Sir, I have to tell the vote of thanks. So, shall I start?
Yes, you can.
Okay. Okay. Thank you, sir. Once again, good afternoon to all of you. As we come to the end of this informative session on engineering advanced materials for energy generation, fundamentals to applications, I feel honored to express my sincere thanks to everyone who made this session successful. First of all, I would like to express my heartfelt gratitude to our distinguished guest speaker, Dr. Bhaskar Sathe sir. Sir, your lecture was very informative, inspiring, and easy to understand. Your explanation of advanced materials are and their role in sustainable energy generation has greatly enriched our knowledge. We are truly thankful to you for sharing your valuable time, experience, and research insights with us. I would like to express my sincere thanks to the UGC Malviya Mission Teacher Training Program, under which this short-term course is organized by Dr. Baba Saheb Ambedkar Marathwada University, Chhatrapati Sambhajinagar. We are grateful to the organizing committee for their vision, guidance, and support in conducting this meaningful academic program. My special thanks go to all the faculty members and organizing team for their dedicated efforts and teamwork, which ensured the smooth and successful conduct of this session. I extend my sincere thanks to all the participants for their active participation and keen interest throughout the session. Finally, I thank everyone who contributed directly or indirectly to the success of this session. We hope that today's session will inspire us to work towards innovation and sustainability in the field of energy and advanced material. With these words, I conclude the vote of thanks. Thank you all. Have a nice day. Thank you, sir.
Yes, thank you, ma'am. Thank you. Yes, next participant. Already sir join हो चुके हैं. Yes, number 23.
Yes, sir, present.
Yes, sir. Already sir join हो चुके हैं. आप सर का बायो कर सकते हैं.
Okay, sir. Good afternoon to all of you. Respected guests, dear participants, on behalf of HRDC, Dr. Baba Sahib Ambedkar, Marathwada University, Chhatrapati Sambhaji Nagar, I, Professor Mudassir from Department of Chemistry, Vidya Mandir Arts, Commerce and Science College, Malegaon City, Autonomous, will you all to today's session. I take great pleasure in introducing our esteemed resource person. Dr. J.A. Kulkarni is the distinguished academician in the field of biotechnology with over 24 years of teaching and administrative experience at undergraduate and postgraduate level. He holds an MSc in microbiology from the Government Institute of Science, Aurangabad, and MTech in Environmental Science and Engineering from IIT Bombay, and PhD in Biotechnology. He is currently serving as a professor and head Department of Biotechnology at Dr. Baba Sahib Ambedkar Marathwada University, Subcampus, Dharashiv, where he has been contributing as a university teacher since July 2005. His academic career includes teaching position, reputed institutions such as Government Institute of Science, Aurangabad, Yashwant Mahavidyalay, Nanded, Netaji Subhash Chandra Bose College, Nanded, VDMD College, Deglur, and NES Science College, Nanded. The Dr. Kulkarni has published 17 research papers, attended around 25 seminars, conferences, and workshops, and has served as a head of department for the last 12 years. His extramural contribution include the development of farmer-friendly biofertilizer production, reactor, ATL, AMRIT, KUMBH, and several technologies supporting sustainable development through a technology development bench. Now I would like to request to Dr. J.A. Kulkarni sir, please conduct the technical session. Over to Kulkarni sir. Kulkarni sir.
Just wait for a moment. Here. Now it's okay. Yeah.
Sir, please
Let
start.
me share my screen. There was a bit technical glitch. Let me share entire screen. Okay, share. And now, yeah. Am I audible now?
Yes, sir. Please.
Yes, sir.
Okay, thank you. Thank you for bearing with my technical glitch. Now I have a bit small question. How much time do I have? Officially, I had 90 minutes, but it will be 6 p.m. I'll try to conclude as early as possible. Being
Okay,
a
sir.
Marathi, in between, I'll be using Marathi language. कभी कभार हिंदी में घुस जाएगी और वो
Okay, sir.
अंग्रेजी के अंदर आ ही जाएगी तो
Okay, okay.
मेरी
No
mixed
issue,
language
sir.
should be pardoned now. Well, this is almost fag end of your FDC. We are almost finishing. So by this time, you must be well aware of the renewable energy or non-conventional energy, like that. Therefore, what I feel is this time to talk something about the policies and their impact, because government and their persons, they do emphasize some policy, they try to make a policy decision, and then it's we who has to pay for that. And so how it came to discussions will be coming. Now, my question is why renewable energy? Because in 2003, Indian government has passed Electricity Act, and then in 2005, National Electrical Policy
आवाज
is
मोठं ठेवायचं नाही ग लक्षात येत
designed, and there it is said that in 1.2 point, electricity is an essential requirement for all facets of our life. It has been recognized as a basic human need, and there is a lot of things it is, etc. But thing is that it has been recognized as a basic human need. Now, if you look back to some time, even today, our farmers are struggling for this basic human need. They don't have electricity daytime; they have to go in the night time, and many things are happening. Let's change. So what it says, the policy in 2005 says, availability of the quality supply of electricity is very crucial to the sustained growth of this segment. This means rural segment. This is being said in that. This policy has recognized that electricity is one of the key drivers for rapid economic growth, poverty elimination. The nation has set itself a target of providing access to all households. What? All household in next 5 years. This is said in 2005. It did not happen as we know this. As per the census, old census, because this data is old, 44% of the household, and according to new census data, uh, something around 30% of the household do not have access to electricity. The reasons are multitude of reasons, but therefore, the meeting target to provide electricity to all is very, very daunting task, very, very difficult task. And it requires generation of the capacity, generation capacity increment, the distribution network improvement, and more so, the manpower involved in the system. The next point is that, therefore, Indian power sector is witnessing major changes. One of the main factors, one of the main sector that is changing is power sector. In our vision, in front of our eyes, things are changing. मुझे याद है कि हमारे पास जो ट्यूबलाइट होता था पहले वो आवाज करने वाला चौक वाला होता था टोंग वाला, अभी नहीं है, अभी बटन है. बीच में वो एलईडी आ गया था, सॉरी सीएफएल आ गया, सीएफएल चला गया, अभी एलईडी आ गया. ये हमारे घर में हमारे आसपास things that are changing, and this subtle change has changed the demography in what are happening today. However, there is substantial peak energy shortage even today. This is due to inadequate generation, inefficient transmission, and losses during distribution. The aims and objectives, they are all old. The access to electricity, availability of power, supply of reliable and quality power to specified standards in an efficient manner at the reasonable rate. ये बात जरा ध्यान से पढ़ने लायक है. What he is saying? Supply of reliable and quality power of specified standards. Why this is important? Even today, many instrument, equipment, household, utility matters, they do get damaged due to the inaccurate electricity. The voltage down, when voltage goes down, our instruments, they fail, they are burned. And even now, when I am talking to you, I had a backup system ready because I don't know when power is going to fail. कब बंद हो जाएगी बिजली किसी को पता नहीं है. अभी इसमें ये भी बताया गया कि पर कैपिटा अवेलेबिलिटी 1000 यूनिट्स बाय 2012 ये हुआ नहीं है. ये सब ये है एम्स एंड ऑब्जेक्टिव है 2005 के पॉलिसी की. फिर भी उसी के गोल्स टू फुलफिल द गोल्स एंड ऑब्जेक्टिव्स इवन टुडे आज की डेट में भी 2026 में भी इंडिया नीड्स टू अडॉप्ट रिन्यूएबल एनर्जी सोर्सेस badly. So what types of energy, renewable energy are available with us? If we look at this figure, as we know, the most famous solar energy. As on today in Maharashtra, most infamous wind energy. Not so much used geothermal energy. Once upon a time, hydropower was considered to be the solution to many things. The hydropower, electricity generation using the power of water, stored water. Then the tidal or ocean energy. And then this is the bioenergy. And finally, it is the hydrogen fuel cells. जो आज के हमारे जो ट्रांसपोर्ट मिनिस्टर है नितिन जी गडकरी, उनकी सबसे फेवरेट चीज है यूज ऑफ हाइड्रोजन एंड यूज ऑफ biologically generated ethanol, bioethanol. These 7 common types of renewable energies includes solar. That's what we discussed. These are derived from natural, inexhaustible resources. इनमें सनलाइट है, हवा है, पानी है, जमीन के अंदर की गर्मी है और जो तुम और हम है ऑर्गेनिक मैटर. अब इधर देखो ये चीज क्या है. जो 5 महाभूत बोले ना, पंच महाभूत, दे आर ऑल हियर. दे आर ऑफरिंग सस्टेनेबल अल्टरनेटिव्स टू व्हाट? टू फॉसिल फ्यूल्स. Kerosene is there, petrol is there, diesel is there, the gas extracted from the soil is there. They're all there in the fossil fuel group. And currently, world is dependent on fossil fuels. Now, if you look at these figures, solar energy, what it does, a very simple thing. It captures sunlight. In the language of physics, is a radiant energy. Excuse me, just a moment. My net is flickering, so I have to put my video off. Yeah, sorry for the disturbance. We have that sort of net problem. So, is the sunlight, which is the waves. For us, is between the 400 nanometer to 800 nanometer, the visible light. But fortunately enough, shorter the wavelength, higher the energy, or the near blue waves or near UV, they can contribute to this solar energy. For that, we need photovoltaic or PV cells. And also, the heat available through sunlight is also extracted, used to generate the electricity. And in this sector, India and world both are working very hard to create smarter and smarter material that would produce more and more electricity per unit area. That is the amount of electricity generated per square meter. So that the size of solar panels should be reduced. As size will be reduced, cost will be reduced. That is on the card. Second thing, the wind energy. If you look at the figure, a huge amount of windmills are being installed. If we go from our Dharashu to Aurangabad, Rambajinagar, sorry, there are many windmills being installed, and the Dharashu district itself is based on the Balaghat plateau, where wind power is sufficiently strong so that it can run the heavy blades. In fact, one of our large panel was dislodged due to the winds. What it does, हमें कुछ दिन पहले की ad है, I don't mean to say anything, but it was very good ad. पहले पंखा आएगा फिर बिजली आएगी. How does it happen? हवा जब बहती है तो उसकी अपनी ताकत होती है, बहुत ज्यादा ताकत. It has the kinetic energy, and it is such a good thing that it can blow turbines. It can run turbines, and when a turbine is run, electricity is generated. It is the electricity and physics, they combine together whenever there is a movement of the coil in the magnet, or magnet is moving inside coil, electricity is generated. The simple principle of physics that I am using, but what is the force that is doing it is the wind. And whatever engineering is done in developing this type of structures. This is just face. The real engineering is inside this structure. The third is the biomass energy. Now, what it happens is carbon dioxide is used by the biological system, particularly plants and few microbes, including unicellular algae. They fix carbon dioxide, convert it into the organic matter, and this organic matter is later on performing life function, and finally it dies and remains as organic material. The many parts of this material are not easily usable by the organisms itself, and it remains in the soil for a long time. Sometimes whatever our activity are there, they generate waste material, organic material. For example, we harvest crop, get the grains, and rest of the things are being let down, and either we burn it out or allow it to remain in the field, or even say for animal manure or like that. These are all biomass, and this biomass has tremendous potential to be converted into energy. That's where the biology and engineering are fusing together to generate the technologies to sustainable production of electricity. The third one is the hydrogen energy. There are two parts for hydrogen. One is the gray hydrogen, produced using the fossil fuel itself again, and next we will be seeing after. Then there is third one, the hydroelectric power, that we say it is the clean fuel. It is the just stored water rushing through the pipes or the thing, and again running the turbine so that electricity generated. The next one, one of the lowest used explode is geothermal and ocean energy. The difference between the surface heat and the core heat can be exploited. The experiments are going on. Substantial amount of success is yet to be achieved. Now, if you look at this thing, each of this area is highly specialized. And what it does mean, it therefore needs special engineering and technology. Not only that, it requires special infrastructure. Infrastructure requirement for production, transmission, and storage are highly divergent. For example, if I am interested in producing electricity by biomass, and I am using the infrastructure for the wind turbine, it is not going to happen. Maybe the base structure for transmission may be same, but the specific infrastructure requirements are different. Therefore, typical engineering or specific technology has to be there, and mostly consumer-based and demand are skewed. For example, the demand of electricity in Mumbai, Pune, Sambhajinagar will be different than suburban areas like Dharashiv or, for example, Parbhani, Hingoli, like any other semi-urban or semi-rural area. They will be different. Therefore, engineering has to be specific, technology has to be developed. Therefore, variety of policies also are required. One single policy cannot be implemented. For example, subsidy to the solar cannot be directly implemented to subsidy to the geothermal energy. No, the requirements are different. Therefore, different schemes are afloat by the central as well as state government to promote the use of non-conventional. Conventional is the fossil fuel. Non-conventional is the or renewable energy sources. Separate schemes, separate policies are there. Actually, these include, these policies include, it includes but not limited to. Who is saying that? Not Jay Kulkarni. As per the information given by the Union Minister for New and Renewable Energy, Mr. Shri R.K. Singh, in a written reply to a question in Lok Sabha on December 7th, he has said that these are the 10 prominent policies or schemes implemented in India currently. Now they are 10 prominent. That does not mean they are only. No, there are many others too. Just take a look at that. There are 3 to 4 areas which are highlighted, and solar has been prominent among them. Now let's go one by one. So that short resume of scheme is there. Now this first is the scheme for development of solar parks and ultra mega solar power projects. हमारे पास एक छोटा गांव है केशी गांव. There they said we are going to generate a 500 megawatt capacity solar park. Nobody did understood. किसी को कुछ पता नहीं चला क्या करने वाला है क्या है. For example, our district, Dharashiv district, is declared as solar district. By the way, we are declared as the underdeveloped or aspirational district for the development under Niti Aayog. Now, this scheme for the development of solar parks and ultra mega project, this scheme, इसका टारगेट देखिए कितना है. 40,000 मेगावाट कैपेसिटी करना है. उसमें क्या क्या इंक्लूड कर रहे हैं वो लोग. Under the scheme, the infrastructure such as land, roads, power evacuation system, water facilities develop करना है. कैसे? With all statutory clearance and approvals. ये बात थोड़ी सी समझ लीजिए. Under the scheme, infrastructure such as land, roads, power evacuation system, water facilities are developed with statutory clearance and approvals. क्यों भाई? So that the scheme should help expeditious development. तुरंत तुरंत जल्दी से फटाफट होना है जिससे इलेक्ट्रिसिटी बन जाए यूजेबल स्केल पे. ये मानना ये है कि डेवलपमेंट ऑफ सोलर पार्क्स एंड अल्ट्रा मेगा सोलर प्रोजेक्ट्स will accelerate India's renewable energy transition, and the figure is staggering. 500 gigawatt non-fossil capacity by 2030 is huge. ये करने के लिए solar parks will be one of the main system. अब इसमें क्या होना है? What we are going to achieve by developing solar parks or ultra mega solar power projects? What is emphasized in the policy is that we will be reducing carbon emission as we are going in mega level. We will be lowering solar cost that will create jobs, and ultimately the final goal will be the energy independence. लेकिन याद रखिए साहब, ये सब करना कहाँ पे है? जमीन पे करना। सोलर पार्क्स ऑन दी लैंड। और यहाँ पे शुरू होती है तकलीफें, क्योंकि when you have to start on land, you have to acquire land. Who is going to acquire? Government or private person? And if I have a bigger acre, why I should allow you to do that? What about the existing animals, existing flora, existing fauna, or in short, what about biodiversity existing at that point? And finally, when you are going for the ultra mega power plant, thing is that you are naturally going on the barren lands where already water is scarce. And when you are creating a ultra project, ultra mega project, it will be using huge amount of water. What is that? Things we deal at detail. What are the key impacts of solar parks and ultra mega projects? First and foremost, environmental and climate impact. इसमें क्या होने वाला है? Reduce carbon footprint. आज की डेट में कार्बन फुटप्रिंट और कार्बन क्रेडिट is one of the most important aspects on global level. In fact, our per capita production of carbon dioxide is lower, so we are having positive carbon credit at global level. Though persons using in large amount of energy intensive product, however, there is a large amount of population that cannot afford to use this kind of product, and our net carbon credit is comparatively low as per the developed countries. So these projects will reduce reliance on fossil fuels, therefore reducing the carbon emission significantly. Therefore, other greenhouse gases. In fact, in other projects like biogas, we are generating methane, which is one of the greenhouse gas. Burning the methane for energy will again generate carbon dioxide. But when we are going for the solar, no gas is being generated. Solar to directly electricity. So we will be lowering greenhouse gas. कितना? अगर 40,000 मेगावाट का solar power plant बन गया, so we will be saving 290 million tons of carbon dioxide, which is huge carbon credit. So that on global level we can trade with developmental activities as well. This is one of the positive impact of this policy, that we are saving on carbon dioxide generation and earning the carbon credits. The second aspect with the environmental and climate impact is the land and biodiversity. When a large scale land intensive project, approximately 5 acres per megawatt, is being constructed, this lead to habitat loss and certain local biodiversity. What this mean? मान लीजिए कि तुम्हारे लिए मेरे लिए जमीन में कुछ है नहीं है, कुछ है बैरन पड़ी है, बंजर जमीन है, दुष्कालग्रस्त है, कहीं नहीं दिखे. I don't know any of you whether have seen the movie by Datta, Border, wherein Sunny Deol, Akshay Khanna, Sunil Shetty, etc. are there. In that, one character says, इस जमीन में पड़ा क्या है? बोले कहा कुछ भी पड़ा नहीं है. बोले then he says, यहाँ पे मेरी सांस है, यहाँ पे मेरी आस है, यहाँ मेरे बिच्छू है, कांटे हैं, वो सब मेरी है. Any land that we see has its own habitat, has its own flora and fauna. When we start cultivating this kind of projects, that local habitat is destroyed, local flora fauna is destroyed. In fact, this has been what happening in the China's mega project, even in our Rajasthan. China में क्यों जाना है भाई? राजस्थान में because the shade that is being created due to the solar panel had changed the temperature structure and the flora and fauna. This is, आप अगर मान ले तो adverse है, आप मान ले तो positive है. But thing is that is changing the ecological system there, mega projects में. यहाँ पे water users बढ़ने वाली है, water users बढ़ने की वजह से conflict बढ़ सकती है, प्लांट में एंड लोकल लोगों में। यहाँ पे हम पॉजिटिव निगेटिव बोथ इम्पैक्ट की बात करना चाहते हैं। इसके बाद में आते हैं इकोनॉमिक एंड इंडस्ट्रियल इम्पैक्ट। भाई ये तो सबसे इंपॉर्टेंट है, वन ऑफ द मोस्ट इंपॉर्टेंट एस्पेक्ट इन द वर्ल्ड इज इकोनॉमिक्स। ये बायोटेक्नोलॉजी, फिजिक्स, इलेक्ट्रिसिटी, इंजीनियरिंग एटसेट्रा, एवरीथिंग कम्स सेकंड। सबसे अहम है वित्त, पैसा। होने वाला क्या है? मेगा प्रोजेक्ट्स। व्हेन वी create a mega project, due to the scale, sheer scale, economics will lead to lower the solar cost. And when it comes to the construction cost is low or the material cost is low, the selling cost can be lowered. ये बात और है कि इलेक्ट्रिसिटी वाले बोर्ड कम नहीं करेंगे, लेकिन मानने में क्या हाल है? स्लोली कम हो रहा है, तो so we should be reducing it. Cost will be reducing, it will be getting more affordable in near future. This will pardon? Okay. These kind of mega projects attract investment from the investors from global level, local level, institutional level. See, when such kind of investment comes from other sources than the state itself, state has funds for the welfare schemes, so that the all welfare schemes can be run efficiently and functionally. For example, health, nutrition, these things can be adjusted by the state provided they have surplus money, and that can be made available by investment of the money by investors, global investors in such kind of projects. Not only that, we are discussing about the economic. This is generating employment. For example, in the metropolitan cities like Bangalore, Pune, Mumbai, Delhi, Calcutta, etc., the people who are working, they don't have time for some sort of household work. So what they do, they call on the platforms. What kind of any platform? Swiggy, Zomato, Apple, you may say Flipkart, etc. And the material is supplied by some sort of person. All these persons are called gig employees, or that kind of economy wherein employment is not permanent, but yes, employment is there. Such kind of employment is generated when such kind of technologies are being implemented. For example, maintenance of the plant or repairment of the plant, all these kind of things, approximately, employment will be generated around the mega projects, wherein therefore the local persons will be employed for the household work or some mechanical work like that. Technical persons will be required, so they will get the jobs, and service-oriented jobs will be there. Anything supply like that. Finally, as there will be the energy security, industry will be willing to go to the area where energy is available. Now, near to this mega power project, if industry is there, a stable current will be available. It will be lower cost due to the less transportation. So there will be the second aspect of the social and developmental impact. No, other than the economic or technical impact, this is more important because whenever somebody is using my land, there is going to be conflict between the landowner and the person who is going to use it. Sometimes by acquiring land, persons may have to be displaced. And in Indian scenario, people, they don't like displacement by force. खुद से होके छोड़ना पड़े तो बात और है, लेकिन किसी को चाहिए, उसकी वजह से मुझे छोड़ना पड़ रहा है, या फिर मेरे बाप दादा की जमीन है, वो 8 वडिलांची जमीन आहे, आठवणी आहे. महाराष्ट्रामध्ये आपल्या थोडीशी पद्धत आहे की खेड्यापाड्यांनी शेतामध्ये आपल्या पूर्वजांच्या समाधी असतात, जमीन घेते ती समाधी तुटते, मानसिक त्रास होतो. That is there. And plus, somebody else decide on the price of my land, that is difficult. Compensation of land in India is seldom satisfactory. People have to struggle decades together to get the आज की आजच्या पेपराचे की संभाजीनगर जिल्ह्यामध्ये शेतकऱ्याचे जमीनचे पैसे देणे होते, कोर्टबाजी झाली, कोर्टाने ऑर्डर दिली, पैसे दिले नाही, मग कोर्टाने ऑर्डर केली की कलेक्टरची खुर्ची जप्त करा. त्याला जर का पहिले पैसे दिले असते तर ही वेळ नसती ना तुमच्यावर. बट इट हॅपन्स. It happens. This is the sort of adverse impact. The positive impact is that when plug and play model is being implemented by the state, maybe state government or central government, that is they are providing एक खिडकी योजना, you may say plug and play एक खिडकी योजना की एका खिडकीत किंवा एका माणसापाशी जमीन मिळणार तुम्हाला. सुरुवातीचं जे काही पॉवर हवे, रोड हवे, हे सगळं एका खिडकीत मिळणार असेल तर तिथं प्रोजेक्ट मेगा प्रोजेक्ट येणार, त्याच्यासोबत बाकीचे पण येणार. नाउ थर्ड वन इज द ऍग्रिकल्चर इम्पॅक्ट इन द सोशल डेव्हलपमेंट टाईप इज दॅट एकाच्या शेतामध्ये प्रोजेक्ट आला तर बाकीच्या शेताची जमीन वापरायची पद्धत, लँड यूज पॅटर्न बदलतो. कारण त्या प्रोजेक्टला येणारे माणसं आहेत, त्यांना लागणारे खाण्यापिण्याच्या वस्तू आहेत, त्यांना लागणारे भाजीपाला, धन धान्य सगळे ना ते बदलते. ट्रॅडिशनल फार्मिंग बदलते. पाणी त्याचं मेंटेनन्स केलेलं पाणी असेल, ते पाणी पिणार तर नाही ते लोक, ते बाहेर येतील, त्याच्या रन ऑफ वॉटरवर इरिगेशन बदलते. मीन्स वेन सच अ प्रोजेक्ट कम्स, agriculture impacts are also there because land use pattern changes, the farming pattern changes. Sometimes what happens, the accessory personnel available at the plant can be used by the farmers for the some course. Therefore, this is also a impact that will be taken into consideration while finalizing the policy. The third one is the technical and strategic impact that may happen due to this mega power projects. Grid stability. When huge amount of power is being generated by solar system, mind that solar power plant generate electricity in daytime. Therefore, it has to go in the hybrid mode. Solar plus wind and storage, large scale, centralized, and hybrid system will improve grid stability. जे ग्रीड फेल होतात की अचानक कुठे पॉवर ओढल्या गेलं की इथे दुसरी काही लाईट फेल झाली, काय झालं, लाईट फेल झाली. दिस बेसिकली ग्रीड फेल्युअर दॅट वेन इट excess amount of energy is added or removed from grid, the grid disturbs and power supply is failed. Now when such a mega power project due to solar is added along with wind, they will provide the grid stability. And finally, these projects, they will incorporate innovation. Why? Because these are requiring huge amount of money. And कोई भी धंधे वाला पैसा खर्च करना नहीं चाहता. So that they will add in, they will invest in some sort of material that will reduce the cost of solar panel. They will add in the material that will generate more and more energy. They will try to develop batteries which could store more and more energy. That is what happening. The second scheme is the Central Public Sector Undertaking, CPSU. Phase 2, or in short, Government Producer Scheme. What it does, it supports grid-connected solar photovoltaic power projects. By whom? By government producers. थोडक्यात काय, महाजेनको, झारखंड जेनको, the MSCBs of different states, वेगवेगळ्या राज्याचे MSCB सारखे जे लोक आहेत त्यांनी स्वतः करायचं. कसं? पाटील म्हणजे तसं नाही बरं. कसं using domestically manufactured solar power cells, photovoltaic cells. But how I am going to use it? Viability gap funding support. हे कोणी करायचंय? डिस्कॉम्स, distribution companies. This scheme phase 2 was implemented for 2019 to 2024. मधल्या काळात कोविडमुळे अजून थोडं एक्सटेंड झालेली आहे. They are the power, 12 gigawatt power has been already been produced. And how much money has been added to that? Look at this. 8,580 कोटी. काय मोजले नाही, म्हणजे 8 ते 9,000च्या मध्ये कुठेतरी पैसे टाकलेले आहेत. And what is doing is it is boosting the Make in India. It is not only boosting the Make in India, due to this project, आपल्याला जो कोल इम्पोर्ट करावा लागत होता, तो कोल इम्पोर्ट कमी झाला. की इम्पॅक्ट काय काय देते? कॅपॅसिटी ॲडिशन आणि इन्फ्रास्ट्रक्चर. यानी जस्ट it has generated 12 gigawatt or 12,000 megawatt of power which is added to grid. And to carry out this electricity at different places, huge infrastructure, वेगवेगळ्या प्रकारचे towers, वेगवेगळ्या प्रकारचे wires has been added and infrastructure has been made robust. By this project, what has happened is domestic manufacturing has been boosted up. कारण या स्कीम मध्ये डोमेस्टिकली प्रीपेड, डोमेस्टिकली सिंथेसाइज फोटोवोल्टिक सेल वापरायचे. हे समजा त्यामुळे काय झालं की as it was necessary to use domestically manufactured cells, they directly provided a support to the local म्हणजे इंडियन सोलार मॅन्युफॅक्चरिंग इंडस्ट्री. एक लक्षात घ्या की थोडंसं भारतीय म्हणजे कसं आहे, इंत भोजनम एल्ला रघु लभ्यसु. जेव्हा पोटभर खाऊ दे मनभर झोपू दे असा आराम आहे. खूप वेळ झालेला आहे की अगोदर आपल्याला क्रायोजेनिक इंजिन दिलं, आपण तयार करून टाकला. सुपर कॉम्प्युटर देत नाही, मला सुपर कॉम्प्युटर तयार केला. वेन वी आर फोर्स टू डू समथिंग वी डू इट एक्सलंट. Now when it is made compulsory to use domestically manufactured, we are preparing domestic photovoltaic cell and good. Now the third impact is that this is viability gap funding. Sometimes what happen, you have a technology, you have some system, you don't have money. Suppose I have a scheme, my introduction person, he was saying ATAL, AM, Atal Amrit Kumbh. This is a technology to produce the fertilizer by farmer itself. We have developed it. We don't have money to propagate it to the farmers. This gap, viability gap. Viable technology is available, but we don't have fund. There is a gap. So this gap is being fulfilled by this scheme. This scheme offers viability gap funding to bridge the gap between the cost of production and the selling price. कभी कभी क्या होता है कि बिजली है लेकिन मैं परचेस नहीं कर सकता. Particularly rural India is facing this problem. So for example, whenever there is a such kind of gap between the selling price and cost of production, that gap is being fulfilled by government, so that the social commitment is followed. And this funding by government make solar projects economically viable. For whom? तुम्हाला मला मिळणार नाही, लक्षात घ्या. फॉर गव्हर्नमेंट प्रोड्युसर्स म्हणजे MSCB, UPSCB वगैरे जे राज्य शासनाच्या 20 कंपन्या आहेत त्यांना मिळणार. Now this kind of support to the government system has reduced the import dependence. जैसे कि मैंने बताया था कि हम कोल इंपोर्ट करते हैं. इट्स नॉट ओनली कोल दैट वी इंपोर्ट, वी डू इंपोर्ट गैस. ईरान से नेचुरल गैस पाइपलाइन आती है. हम क्रूड ऑयल लेते हैं. आज की डेट में भारत को जो तकलीफ हो रही है ट्रम्प ताता की वजह से, वो तेल का तो मामला है. हम रशिया से सस्ता तेल लेते हैं, तात्या बोलते हैं कि नहीं भाई महंगा तेल लो मेरे दोस्ती की तरफ से. हम बोलते हैं नहीं भाई हमें प्रवर्तन नहीं है. तात्या बोलता है कि मैं टैरिफ लगा दूंगा. अगर हमारे पास अपनी खुद की पावर रहेगी, खुद का जस्ट पूरा सप्लाई रहेगा, तो तुम बोलोगे कि भैया सर वो तो मेरी गाड़ी का पेट्रोल लगता है. भैया अगर बिजली सस्ती मिलने लगे तो ईवी लेंगे नहीं. आपकी जानकारी के लिए बता दूं मैं कि मैं जब धाराशिव में पहली बार था 2005 में, 2006 में एक ईवी आई थी, हमने देखी थी. इसका नाम आई थिंक जियो जियो नहीं था, जॉय राइड, जॉय था जी. यूज नहीं किया लोगों ने. अब पेट्रोल के भाव बढ़ गए, इलेक्ट्रिसिटी के भाव तुमसे हाथ में आ गए, हम ले रहे ना. लाइक दैट दिस इनिशिएटिव हैज dependency on imported has been addressed, and now due to this kind of thing we are reducing the import because we are making slowly so called atmanirbhar supply chain. Now next one is green power for government. The generated electricity is intended for self use by government entity. जो भी जनरेट बिजली बनने वाली है वो यूज कौन कर रहा है? डिस्कॉम्स. डिस्कॉम हमको बेच रहे हैं, लेकिन बाय दिस सेल एंड परचेस, प्रोडक्शन एंड परचेस, वट एवर प्रॉफिट इज देयर. कोई भी चीज किसी को फोकट में तो नहीं देगा, बेचेगा तो प्रॉफिट कमाएगा. प्रॉफिट आ रहा है, एंड तो कौन कमा रहा है प्रॉफिट? गवर्नमेंट कंपनीज, डिस्कॉम्स. एंड देयर बाय वी आर अडॉप्टिंग ग्रीन एनर्जी in public. And now finally this scheme is implemented by IREDA, India's Renewable Energy Development Authority, IREDA. ये लोग जो भी पूरा इम्प्लीमेंटेशन है, इट इज हाईली ट्रांसपेरेंट. हम में से कोई भी कभी भी किसी भी वेबसाइट पर जाके चेक कर सकता है. ट्रांसपेरेंसी इज बीइंग एडेड टू द गवर्नमेंट फंक्शनिंग. माना कि आज भी कंप्लीट ट्रांसपेरेंसी नहीं है, लेकिन नई मामू से लगता हूं कभी भी अच्छा है, थोड़ी तो है. तीसरा पॉलिसी है, तीसरी स्कीम है, दिस इज समथिंग इंसेंटिव टाइप स्कीम. नेशनल प्रोग्राम ऑन हाई एफिशिएंसी सोलर पीवी मॉडल्स. अभी पिछले लेक्चर में जब साठे से बोल रहे थे कि एफिशिएंसी बढ़ा रहे हैं भाई, उसके लिए गवर्नमेंट ने बहुत सारी पॉलिसी बनाई है, बहुत सारी सब्सिडी दी, पैसा भी अवेलेबल कर दिया. ये पैसा कितना दिया है? 24,000 करोड़. उससे हो क्या रहा है? इज रैपिडली ट्रांसफॉर्मिंग द इंडिया इनटू अ सोलर मैन्युफैक्चरिंग हब. नॉट ओनली इंडियन रिक्वायरमेंट, it is going to supply to the neighboring developing countries for solar. आज के डेट में जो भी लोग हमारे से आगे पीछे माँ मुंह भोड़ के उल्टा सीधा दुश्मनी की तरफ बहस कर रहे हैं, रुकिए. आने वाले 10 सालों में इन लोगों को सोलर के लिए हमारे पास आना है, क्योंकि आज की डेट में भी इंडिया इज अ गुड व्यापारी देन द चाइना. So this is driving 1.5 lakh direct or indirect jobs and supporting our energy target of 500 giga. अब इसकी की इम्पैक्ट स्कीम के क्या है? सोशल, टेक्निकल, इकोनॉमिकल वगैरह वगैरह वगैरह. सबसे अहम है कि ये स्कीम से 40 गीगावाट एनर्जी बनने के स्ट्रक्चर्स बन रहे हैं. इतने बड़े पैमाने पे जब पावर सप्लाई में पैसा उतर रहा है तो डेवलपमेंट तो होना लाजमी है। इसमें क्या क्या है? इसमें पॉलीसिलिकॉन सेल, वेफर्स, वेफर एक टेक्नोलॉजिकल टर्म है, जब पतला वाला चीज होती है खाने का वेफर, तो ये पतला वाला सर्किट डिजाइन फिल्म दैट कैन बी यूज्ड इन द सोलर पैनल, वो होता है। और इसके साथ मिला के एक पूरा मॉडल बनाना है, इसके लिए पैसा दिया हुआ है 24,000 करोड़। देन दिस इज गोइंग टू रिड्यूस द इंपोर्ट, इसके लिए 17,500 करोड़ मान लिए। दीज आर दी फिगर्स इन बजट, वी कैन गो, वी कैन चेक इट एनी टाइम। तो इतना दे कि 17,500 का पैसा दिया है, सो दैट हम लोगों का इंपोर्ट डिपेंडेंस, पर्टिकुलरली चाइना पे हम डिपेंड है, चाइना भी बोलता है कि नहीं मैं नहीं दूंगा, हमारी तरफ से सुधार बंद, वो कम हो जाए। क्यों? तो ये पैसा आगे वाले एक दो स्कीम मिला के वी आर डेवलपिंग एनर्जी एफिशिएंट मटेरियल so that India become a major power in solar और non renewable energies। इसकी वजह से जॉब क्रिएशन होने वाली है। मान लीजिए कोई भी बड़ा प्रोजेक्ट आता है तो जॉब तो आते हैं। औरंगाबाद जो संभाजीनगर का एग्जाम्पल लक्षात घ्या, when there was Bajaj Auto fully functional, huge amount of money was in circulation in market। when Bajaj बंद पड़ गया उसके बाद में कई सालों तक औरंगाबाद में रेसिशन था, अभी बाकी के फिर आगे सब बढ़ गए तो फिर पैसा घूम रहा है। when money is circulation, money generates, it's पैसा घूमने वाला है तो job should be there। what type of job should be there? in logistics, ancillary services, those kind of jobs should be there through this scheme। not only that, this scheme will be developing many technologies, they'll be developing high efficiency, some technological term like monopole, top pack। पिछली वाली जो है ना पुरानी टेक्नोलॉजी जो थोड़ी कम एफिशिएंट है, जो अभी आई थिंक सम लाइब्रेरियन सर शेरमन शेरेकर बोल रहे थे, बदलना पड़ेगा, जरूर बदलना पड़ेगा। नया एफिशिएंट सिस्टम आ रहा है। नॉट ओनली दैट, इसके साथ में बाकी केमिकल सिस्टम में भी, जैसे इथिलीन विनाइल एसिडेट वाली कंपनीज है, एंशियल इंडस्ट्रीज आएंगे। मान लीजिए ग्लास बनाना है, सोलर ग्लास, ग्लास की इंडस्ट्री बढ़ेगी। इसके बाद जब बैक का पॉलीमर इंडस्ट्री है, पॉलीमर इंडस्ट्री बनेगी। बाकी छोटे मोटी चीजें होती है, जंक्शन बॉक्स वगैरह वगैरह, वायर वाले, पूरी इंडस्ट्री बढ़ने वाली है। लोकल लेवल पे जो स्टैंड बनेंगे छोटे बनाने के लिए भी ये बात चल रही, बड़े बड़े प्रोजेक्ट की, वहां पे वेल्डर्स है, टर्नर्स है, फिटर्स है, उनकी जॉब है। ऐसे इंडस्ट्री विल ग्रो एंड ये सबका इंपैक्ट करने वाला है कि हमारा जो गोल है 2030 तक 500 मेगावाट का वो मिलेगा। एंड एक्चुअली फाइनल गोल ऑफ इंडिया इज टू गेट द नेट जीरो emission, that is the carbon dioxide emission zero। we have set the goal at the 2070। जैसा कि भास्कर सर ने बताया था कि 2030 का जो टारगेट था सोलर पावर प्लांट्स टू द फार्मर्स, हमने 2025 में यूज कर लिया है। वी आर अहेड ऑफ टाइम। That's what we are coming in the next is the, this is what PM question is। this is to promote the small ग्रिड कनेक्टेड सोलर पावर प्लांट। अभी तक जो हम बात कर रहे थे बड़े बड़े प्लांट की थी, 500 करोड़, 200 करोड़, 1000 करोड़, 17,000 करोड़, 18,000 करोड़। भाई हम छोटे आदमी हैं, पेट के पूता मिलना है हमको, ये यहाँ पे आ गए। प्रमोट स्मॉल ग्रिड कनेक्टेड सोलर एनर्जी पावर प्लांट। ग्रिड में लगाएंगे, छोटे छोटे लोग हैं, या फिर स्टैंड अलोन 2-4 एकड़ का प्लांट है उसके लिए भी है। यहाँ पे किस चीज के लिए? इसके साथ में हमको करना है सोलर पावर्ड एग्रीकल्चरल पंप्स एंड एग्जिस्टिंग ग्रिड जो भी है, तो खेती को बीज देती है, बिजली देती है, उसको हमें ग्रिड में लाना है, उसके अंदर सोलर का पावर ऐड करना। होने आना क्या है, ये इज नॉट ओनली बेनिफिशियल टू फार्मर्स। तो वो लगता है कि किसानों के लिए, नहीं भाई किसानों के लिए नहीं है ये चीज, डिस्कॉम्स, महावितरण, उनके लिए भी बेनिफिशियल है। क्यों? अब ये सवाल है कि क्यों भाई, उनको बेनिफिट क्या है? अगर एक बार तुमने सोलर पावर प्लांट दे दिया किसान को, भैया उसको सब्सिडी देने की जरूरत नहीं लाइट पे। आज होता क्या है कि किसान के नाम पे सब्सिडी बाकी के लोग दूसरे छोटे मोटे कामों के यूज करते हैं। अभी उसको हमने दे दिया है सोलर पावर प्लांट, सोलर पावर्ड पंप, तो बीज देंगे नहीं पावर पंप के लिए। ये खतरा भी है, ही एक प्रकारची धोक्याची घंटा आपल्याला लक्षात घ्या. आम्ही तुम्हाला सोलार पंप दिलेला आहे, आम्ही त्यामुळे वीज देणार नाही. सोलार पंप खराब झाला तर काय करायचं ते पुढे घे, पण ती धोका आहे लक्षात घ्या. पण ॲज ऑन टुडे बाय प्रोवाइडिंग पंप टू अंडर पीएम कुसुम स्कीम, ये डिस्कॉम को बेनिफिशियल है, फार्मर के तो बेनिफिशियल है क्योंकि उसको दिन में पानी देगा भाई वो. एंड फाइनली जो अभी थोड़ी सी बात डिस्कस हुआ था ना कि बनने वाली बिजली एक रेट से लेते हैं और देते वक्त दूसरे रेट से देते हैं, ये तो फिर सोनार की तरह हो गया, सोनारासारखं झालं. घेताना एक भाव तो सोन्याचा, विकताना दुसरा भाव, मधला जो असतो फरक तो प्रॉफिट. लाइक दैट सेम थिंग, discoms will be purchasing your electricity at lower rate and selling at the higher to somebody else, because this is धंधा. तो इसके इम्पैक्ट क्या है? व्हाट आर द की इम्पैक्ट्स ऑफ द पीएम कुसुम स्कीम? फाइनेंशियल बेनिफिट टू पीएम, सॉरी, फाइनेंशियल बेनिफिट टू फार्मर्स क्या क्या है? कॉस्ट कम होना, ये बिजली नहीं दे रहा है तो भी डीजल का पंप लिया है किसी ने. हरियाणा, पंजाब, नॉर्थ इंडिया में डीजल पंप दे आर वेरी कॉमन. रिप्लेसेस डीजल पंप विद सोलर पंप्स, saving roughly 50,000 annually per 5 HP pump. जिथे वीज आणि जे पंप होते इथं रात्री बेरात्री जागावं लागायचं ते हुकलेलं आहे. जिथं डिझेल पंप वापरायचे तिथं ते डिझेल पंपची कॉस्ट वाढणार आहे. इथे जर का सरप्लस वीज सहजपणे घेतली, वीज कंपनीने सहजपणे घेतली तर तुम्हाला एक एक्स्ट्रा इन्कम आहे. हे प्रोजेक्टेड इम्पॅक्ट आहे, ते एक्स्ट्रा इन्कम येईल. काही जणांना मिळते. असं तुम्हाला असंही करतं की बा 5-10 शेतकरी एकत्र या, सोलार पंप ते जनरेट करा आणि त्यातून दुसरं तयार करा. पण इथे पॉवर डिस्ट्रीब्युशन कंपनी तुमचं वीज विकत किती पद्धतीने कसं घेते ते माहिती. तिसरं आहे युटिलायझेशन ऑफ द बॅरन लँड. इथे ते मात्र होते की बऱ्याच जणांचे पोरं बाळं मुंबई, पुणे, दिल्ली, कलकत्ता, न्यूयॉर्क, लंडन गेले आहेत, जमीन पडलेली आहे किंवा जमीन मिळतेच जी काही असेल ती महाराणाची जमीन आहे. अशा महाराणाच्या जमिनीमध्ये तुम्ही छोटासा सोलार पॉवर प्लॅन्ट टाकून त्यातली जी काही इन्कम आहे ते विषयता, किंवा त्यातनं जे काही तुमचं पंप वगैरे वापरून ती जमीन कल्टिवेबल करू शकते. असं त्याच्यामध्ये दुसरं काय ना की ॲग्रिकल्चरची इम्प्रूव्हमेंट कशी झाली की ऑपरेशन. इथे मात्र तुम्हाला लाईफस्टाईल मध्ये थोडासा फरक पडणार. दिस विल प्रोव्हाइडिंग यू रिलायबल डे टाईम पॉवर. तुमचा स्वतःचा पंप असेल, आकाशात सूर्य असेल, साधारणतः वर्षाचे 40 दिवस असतात तिथं सूर्य अजिबात येत नाही. पूर्वी जरा जास्त झाली, आता जास्तीत जास्त 40 दिवस पाऊस पडतो, धो धो धो. बाकीचे म्हणजे वीज कमी पडेल असत. बाकी 320 दिवस सूर्यप्रकाश वीज तयार करण्याचा नक्कीच असतो. त्यामुळं आपणाला डिपेंडेबल डे टाईम वीज मिळेल, जे काही रात्री ते इच्छू काढे बाकी सगळं थांबणार. त्यामुळे तुम्हाला MSCB वरचं डिपेंडन्स कमी होईल, माणसावरचं डिपेंडन्स कमी होईल, किंवा पीक समोर आलेलं आहे आणि पाणी नेहमी सुकते म्हणजे जी की मानसिक त्रास होतो तो कमी होऊ शकतो. आणि वेळच्या वेळी ठीक आहे, जास्त पाणी द्यायचं नसते, पण ते वेळेवर जर का दिलं ना पिकाची प्रोडक्टिव्हिटी, ते एखादं बॉटणीवर असं ते लक्षात येईल, त्या वेळेस त्याला पाणी देणं गरजेचं असते. जसं काही फळझाडांना त्या विशिष्ट वेळेस पाणी तोडणं गरजेचं असते, विशिष्ट वेळेस पाणी देणं पण गरजेचं असते. हे आपल्या हातामध्ये आहे, माझी मर्जी राहील पाणी द्यायचं नाही द्यायचं. जर का हे ऑपरेशनल प्रॉपर केलं तर. हे असं झालं तर प्रोडक्टिव्हिटी इन्क्रीज होईल, यील्ड वाढणार आहे, ते नॅचरल आहे. वेळच्या वेळी पाणी जर मिळालं तर प्रॉडक्टिव्हिटी वाढणार आहे आणि हे आपल्या प्रकारच्या स्वतःच्या पंपावर होणार. आणि त्यामुळे आता तिसरा परिणाम काय झाला की ऍग्रिकल्चर किंवा फार्मिंग विल बी सस्टेनेबल. कारण इथे तुमचं डिझेल पेट्रोल वगैरे काही मिळणार की शक्यता अशी काही दिवसामध्ये रस्त्याने जे काही आता सध्या डिझेलचे ट्रॅक्टर आहेत ते काढून लोकांनी इलेक्ट्रिकचे ट्रॅक्टर यायला लागले ते मला आश्चर्य वाटणार नाही. त्याचे इन्व्हायरमेंटल इम्पॅक्ट काय? नॅचरली डिझेलचा वापर किंवा फॉसिल फ्युएल बेस्ड इलेक्ट्रिसिटीचा वापर केल्यामुळं कार्बन इमिशन कमी होणार आहे. हातामध्ये तुमच्या पंप असल्यामुळं वॉटर कन्झर्वेशन होणार आहे. इथे सिंगल आहे तो निगेटिव्ह इम्पॅक्ट कुठे होता? मोठ्या मोठ्या प्लांटमध्ये वॉटर स्केल्स यांचे असतात. इथे तुमच्या ताब्यामध्ये तुमचा पंप आहे त्यामुळे तुम्हाला वेळच्या वेळी हवं तेव्हा पाणी जाईल. एरवी जेव्हा वीज असतं तेव्हा पाणी देऊन घ्या, त्यात पाण्याचा लॉस होऊ शकतो होत होता न. आणि सगळ्यात शेवटी काय होणार आहे की यातनं जे काही वीज उडणार आहे किंवा तुम्ही वापरणार आहात ती वीज ही सस्टेनेबल वीज आहे, ती वीज ही इको फ्रेंडली वीज आहे. त्यामुळं वी आर कॉन्ट्रीब्युटिंग टू इंडिया रिन्युएबल एनर्जी टार्गेट. यातनं अजून एक काय होणार आहे की खेड्यापाड्यांनी वाडी तांड्यांनी छोटे मोठे जॉब डेव्हलप होणार आणि या असे जॉब डेव्हलपमेंटमुळं इंटेरियर युथची एम्पॉवरमेंट होणार आहे. या शेतकऱ्यांसाठी झालं. पुढची स्कीम आहे मध्यमवर्गीय शहरी लोकांच्या आवडलेली रूफटॉप सोलार प्रोडक्ट. पाणी पितं थोडंसं. नो दिस इज कनेक्टिंग टू सोलार. इथं थोडस लोकांची भरतोय तर आपण करतोय पण तुझी नाराजी आहे की पीएम सूर्यघर मुफ्त वीज योजना मुफ्त वगैरे काही पण पीपल आर युझिंग, पीपल आर अप्लाइंग, पीपल आर इन्स्टॉलिंग. या स्कीम मध्ये सगळ्यात महत्त्वाची सबसिडी दिली जाते आणि त्यातून मग ते पुढे लोक इन्स्टॉल करतात. त्याची इम्पॅक्ट काय काय? रेसिडेन्शियल सेक्टरवर आहेत, इन्स्टिट्यूशन सेक्टरवर आहेत. सगळ्यात महत्वाचं आहे रिड्यूस इलेक्ट्रिसिटी बिल. अथवा आमचं एक्झाम्पल, आमच्या सब कॅम्पसला अप्रॉक्सिमेटली 80,000 बिल आहे. आम्ही आमच्या सब कॅम्पसमध्ये रूफटॉप सोलार सिस्टीम बसून घेतलेली आता 10 ते 12,000 आपण बिल आहे. हा पैसा सरकारचाच आहे पण आता जे आमच्या एक बर्डन असते किंवा इन्स्ट्रुमेंट वापरताना वीज जळते वगैरे ते बर्डन जर कमी झाले. आणि हे ज्यांच्याकडे रूफटॉप सोलार बसवायला आहे. आता आमच्या बरेचसे मित्रांनी काय केलंय, व्हॉट दे डिड, दे हॅव इन्स्टॉल्ड रूफटॉप सिस्टीम सो दॅट दे कॅन परचेस ईव्ही किंवा दे हॅव परचेस्ड ईव्ही अँड इन्स्टॉल्ड रूफटॉप सो दॅट दी फ्रीली अवेलेबल सिंगल कोड बरं का, नथिंग इज फ्री. पण ती अवेलेबल जी आहे इकॉनॉमिकल अवेलेबल क्लीन एनर्जी दे आर युझिंग इट अँड दे आर enjoying the benefits of electricity at low price. Reduce it. There is substantial subsidies under central finance assistance up to 40% for first 3 kVA, first 3 kilowatt, and furthermore 20%. But still, this subsidy is sufficiently useful for installation of small rooftops. Now, some of the consumers, which are wise enough, they are carefully adjusting their cycles of electricity use. केव्हा यूज करायची केव्हा नाही करायची असं करत दे आर सेलिंग सरप्लस टू दी ग्रीड. आता एक कोणाला आहेत ज्यांनी पहिल्या स्कीम्स मध्ये घेतलेत ना त्यांना फायदा आहे. नंतर त्यांना MSCB वाले पण शहाणे झाले, त्यांनी कंडिशन बदलल्या. आपली वीज ते एवढ्या वेळातच घेणार, एवढं नाही घेणार, दिवसात वापरा, दिवसाच्या निवृत्ती असं केलंय. पण देयर इज दी अगेन दी ऑपरेशन कॉन्फ्लिक्ट दॅट विल बी सॉर्टेड आउट. द सेम थिंग it is improving the energy security. And again, due to this improved energy security, there is independence is coming out. Environmental sustainability is there. It is adding to the CO2 reduction. It is millions of tons एक प्रोजेक्ट जो असतो काही मिलियन टन असतो 25 इयरचा लाईफ स्पॅन आपल्या प्रोजेक्टचं ते 25 इयर म्हणतात. आता जसं भास्कर सरांनी सांगितलं 10 ते 12 वर्षामध्ये टेक्नॉलॉजी इतकी बदलते की आपल्याला तो चेंज करणं परवडतं. तिथे याच्यामुळे काय होतं की नॅशनल डिटरमाइंड कॉन्ट्रीब्युशन NDC जे आहे ना ते शेवटचे जे आहेत ना सस्टेनेबल क्लायमेट गोल्स हे आपल्या लेवलला फारसा फरक करत नाही. पण एक एकटा असे खूप लोक कोट्याधी लोक एकत्र येतील ना ग्लोबल लेवलला इंडियाज कॉन्ट्रीब्युशन टू द क्लायमेट चेंज इज काउंटेड. नाउ दिस rooftop system is empowering DISCOMs as driver and याच्यामुळे डिस्कॉमला जर का सूर्यघर योजनेत जास्त झालं असेल तर त्यांना परफॉर्मन्स लिंक इन्सेंटिव्ह पण मिळतोय. कारण त्याच्यामुळे त्यांना टाकतायत आणि शेवटी लोकली इन्स्टॉल सिस्टीम असल्यामुळं डिस्ट्रीब्युशन लॉस व्हायचा. कारण वीज जेव्हा तारातून वाहते तार गरम होते तार गरम होताना विजेचा लॉस होतो. आपल्या जर का वीज बिल बघितलं त्याच्या मागे ट्रान्समिशन आणि डिस्ट्रीब्युशन लॉस TDL नावाचा प्रकार असतो ते कमी होईल. तो त्यांचा फायदा आहे. चौथा बेनिफिट जातो तो इकॉनॉमिक मध्ये ड्यू टू दी लोकलाइज डिसेंट्रलाइज ना प्रत्येक घराघरावर इन्स्टॉलेशन करायचं आहे त्यामुळं जॉब क्रिएशन होते. अप्रॉक्सिमेटली 1 मिलियन 10 लाख जॉब पर इयर कोणाचे स्किल्ड आणि अनस्किल्ड हे आलेले इन्स्टॉलेशनसाठी मेंटेनन्ससाठी प्रोजेक्टसाठी. साधी गोष्ट की आज तुम्ही इन्स्टॉल केलं असेल त्या पॅनलवर धूळ बसते. धूळ साफ करायची म्हणलं की DC करता झटका लागू शकतो. मग धूळ कोणी साफही करत नाही. पावसाळा यावा पाऊस पडावा ते धुवून जावं. सिंपल थिंग आहे की यू डिझाईन अ सिस्टीम जेणेकरून छोटा ड्रोन मिळतो ॲग्रिकल्चर ड्रोन त्या ड्रोन मध्ये पाण्याचा स्प्रे मारायचा फोरायचा. एक 5-10 गावामध्ये एक ड्रोन ठेवला तुम्ही झालं सिस्टीम तयार. इट इज क्रिएटिंग अ जॉब किंवा वेल्डर्स आहेत फिटर्स आहेत जॉब क्रिएशन. अगेन दिस इज गिग इकॉनॉमी. जॉब क्रिएशन आहे लगेच त्याला 1 तारखेला सॅलरी येणार आहे तर PF कटणार आहे त्याला ग्रॅच्युटी ना बट येस ज्याला गिग इकॉनॉमी म्हणते की ज्याच्याद्वारे आज भारताची GDP वाढतोय तर गिग इकॉनॉमी जॉब विल बी देअर. आणि वीज अशी लोकल लेवलला रूफटॉप सोडणी अवेलेबल झाल्यामुळे घरगुती जे बिझनेस छोटे मोठे चक्की असेल कुठेही ज्याला वीज लागते मसाले वगैरे सगळे छोटे छोटे प्रोग्राम हाऊस होल्ड कॉटेज इंडस्ट्री विल बी डेव्हलप. that will be developing domestic manufacturing. Again, हे कॉटेज इंडस्ट्री झालं. सोबतच हे छोटे रिक्वायरमेंट्स आहेत रूफटॉप सोलार वगैरे पॅनल छोटे आहेत याला सगळे लोकल इंडियन सोलार मॅन्युफॅक्चरला जावं लागणार आहे. स्कीम करताना मला इम्पोर्टेड चालणार नाही. आणि ह्याच्यामुळं सगळं सिस्टीम हे झाल्यामुळं प्रोसेस स्ट्रीमलाईन झाली. नॅशनल पोर्टल बनलेलं आहे प्रोसेस स्ट्रीमलाईन नाही. बरे आता तर काय की बाबा तुम्ही या मला हे करायचं म्हणा समोरचा जो माणूस आहे सगळं तुम्हाला करून आणून देतो. प्रोसेस हा स्ट्रीमलाईन इज मेजर. कारण मी माझा दिवस घालू शकत नाही. जो समजा रेग्युलर वर्क नाही काम करणारा माणूस आहे तर दिवसाचा रोजगार म्हणून कोणी जाणार नाही. समबडी इज डुईंग कारण ही प्लॅटफॉर्म बेस्ड प्रोसेस स्ट्रीमलाईन झाली त्यामुळे. पुढचं आहे ग्रीन एनर्जी कॉरिडॉर्स. हे सरकारने क्रिएट केले. हे इंटरेस्टेड वेगवेगळ्या राज्यामध्ये जे ग्रीड आहे एकमेकाला बनलेली एनर्जी ती देण्यासाठी कुठली रिन्युएबल एनर्जी प्रोजेक्ट्स. आता ह्याच्यामध्ये कुठलाही एनिथिंग दॅट इज अदर दॅन फॉसिल फ्युएल कम्स अंडर रिन्युएबल. हे सगळे एकमेकात गुंतवायचे एकमेकात लावायचे. आणि हे सगळ्यांना सेंट्रल फायनान्शियल असिस्टन्स आहे. आणि त्यामुळे हे ग्रीन एनर्जी प्रोजेक्ट जे आहेत ना हे एनर्जी ट्रान्झिशन्सला सिंक्रोनाइज करते. दे आर इंटिग्रेटिंग विथ इच अदर सो दॅट कार्बन इमिशन्स डिकार्बोनेशन वगैरे प्रचंड प्रमाणामध्ये करायची. साधारणतः 1,000,000 टन कार्बन इमिशन थांबवायचं या ग्रीन एमिशन कॉरिडॉरने होणार. हे ग्रीन एनर्जी कॉरिडॉरचे इम्पॅक्ट काय काय? जसे की एनर्जी टार्गेट जी आहे ना फॉसिल फ्युएलचं कमी करायचं. किती ना अप्रॉक्सिमेटली 450 गिगावॅटचं जी काही वीज आहे त्या लेवलची जी काही वीज आहे ती ग्रीन एनर्जी कॉरिडॉरनं फिरली पाहिजे. मग काय होणार आहे की ॲज दिस होल सिस्टीम इज बिंग इंटिग्रेटेड एकत्र आणल्यामुळं ही ग्रीड विल बी स्टेबल. ही लक्षात घ्या की ही सगळी रिन्युएबल एनर्जीसाठी बनलेली ग्रीड आहे. त्यात काय होणार की रिसोर्स रिच स्टेट फॉर एक्झाम्पल कोस्टल भाग आहे, कोस्टल आंध्र आहे, कोस्टल केरळ आहे, कोस्टल म्हणजे इथं प्रचंड प्रमाणे वारं सुटले असते. इथं विंड एनर्जी बनणार मध्ये देणार. ते छोटं राज्य आहे गोवा, इथं बनली वीज महाराष्ट्रात पाठवा. कोस्टल कर्नाटकातून ग्रीड बनल्यावर कुठून कुठं फिरणार. किंवा इंटेरियरचं राज्य जिथं काही गोष्टी म्हणजे या गोष्टी कमी आहेत किंवा खूप नॉर्थ इंडिया हिमाचल प्रदेश थोडंसं ऊन कमी आहे तर वाचते ड्यू टू construction of a grid dedicated for the renewable energy, the movement of electricity will be possible. Mind that the transmission distribution loss होईल पण थोडंसं काही अवेलेबल होईल. As usual, any non-conventional or renewable energy will benefit to the environment. This will lead to economic growth. लक्षात घ्या की पॉवर आला, पॉवर म्हणजे इलेक्ट्रिसिटी, डेव्हलपमेंट आली की इकॉनॉमिक ग्रोथ आली आणि दिस विल अगेन लीड टू द इन्फ्रास्ट्रक्चर डेव्हलपमेंट. जस्ट अ मिनिट, we check time. Now, under the bioenergy program, there are two main things. One is waste to energy program, other is biogas program. In 2018, I think it was Sitaraman's first or second budget, she had allocated approximately 1 lakh crore rupees for integrated biogas program. 1 lakh कोटी रुपये बायोगॅस साठी. म्हणजे स्टॅगरिंग फिगर आहे ना. अँड लास्ट 10 years पूर्वी जे होतं की छोटे छोटे घरोघरीचे बायोगॅस प्लांट ते फेल जायचे, टेक्निकल कारण होते त्याला. सो इंडियन गव्हर्नमेंट इज ॲडिंग टू दॅट ऑन वेस्ट टू एनर्जी प्रोग्राम. दिस इज दी all sort of organic matter, all sort of burnable matter. It is converted into such kind of residue that it could be converted into some or other sort of energy, particular other. Now, this whatever biomass is there, it can be converted into briquette. बॉयलरला जाळत्यासारखे लाकडाच्या ठोकळ्यासारखे ठोकळे बनवायचे और बगॅस सोडून दुसरं बाकी सगळ्याला कन्वर्ट करायचं, गॅसिफिकेशन करायचं बायोमासचं. पण अदरवाईज इट इज गोइंग टू लाय ऑन द ग्राउंड, डिके अँड रिलीज कार्बन डायऑक्साईड अननेसेसरीली. इथे जेव्हा केव्हा ब्रिकेट करणार आहात तुम्ही, त्याला जाणार आहात, इथे पण कार्बन डायऑक्साईड बनणार आहे, पण इथल्या कार्बन डायऑक्साईडची एनर्जी विल बी कन्वर्टेड इनटू इलेक्ट्रिसिटी. It will be converted into the some sort of usable energy form. जर का जमिनीवर पडल्या झालं ते कार्बन डायऑक्साईड तर काहीच उपयोग नाही. अँड सेकंडली ऑल सच काइंड ऑफ डिग्रेडेबल मटेरियल इफ इट इज यूज्ड अंडर द बायोगॅस प्रोग्राम, डायरेक्ट बायोगॅस कॅन बी जनरेटेड. इम्पॅक्ट कसे आहेत? वेस्ट टू एनर्जी मध्ये काय होतं? Either it is converted to heat or energy, so electricity. Whatever in the case, it is ultimately the renewable energy. And organic matter can be regenerated by biological system. To some extent, these biogas waste to energy programs are efficiently converting 40 to 50%. What is next impact is very useful. By converting waste to energy, we are reducing the dependence on landfill. कचऱ्याचे जे काही ढीग आहेत ना, कुठल्याही छोट्या मोठ्या शहराला जा, आमच्या धाराशिवला पण या, बायपास येताना ना कुठे जावं लागते तुम्हाला. Landfills. Now, if biomass is properly segregated and used for waste to energy conversion program, up to 90% volume can be reduced. And by converting waste to energy, we are removing the greenhouse gases. I'm going a bit fast, right? This is again generating energy and creating stability. Not only that, converting waste to energy is going to recover resources. However, there are some enormous challenges. Like WT, waste to energy मध्ये कधी कधी जाळपोळ म्हणजे जाळताना कसा डायऑक्सिन सारखी गॅस तयार होऊ शकतात किंवा डस्ट मटेरियल पार्टिक्युलेट मॅटर येऊ शकते जेणेकरून एअर क्वालिटी इंडेक्स कमी होऊ शकते. कधी कधी वेस्ट टू एनर्जी मधले इन्स्ट्रुमेंट इक्विपमेंट सोफिस्टिकेटेड लागतात, दे आर एक्सपेन्सिव्ह आणि काही ठिकाणी जसं इन्सिनेटरला हाय टेक पोल्युशन कंट्रोल सिस्टीम लागतात, हे पण इनॉर्मस चेंजेस आहेत. हावेवर वेस्ट टू एनर्जी टेक्नॉलॉजीज ज्याच्यामध्ये कंबशन पण आहे, anaerobic digestion पण आहे, गॅसिफिकेशन आहे, they act a crucial link in sustainable waste management and the secondary aspect of energy transition. There are more things, but however, I think we are short of time. It is 4 minutes to 6. I'll just keep these things. And finally, we'll go to the last bit. There is green hydrogen that will be produced using water and renewable energy. Its expected outcome is 4 million metric ton of hydrogen, 125 gigawatt of renewable energy, and it should create 6 lakh jobs per annum. This is my final concluding slide. As on today, India is trying very sincerely to achieve its renewable energy goals. In fact, on 21st of January 2026, day before yesterday, Press Information Bureau, India has published its draft electricity policy 2026, wherein a national green and renewable energy is highly relied upon. The very aim of 500 plus gigawatt power generation via non-conventional, non-fossil fuel base is impacting our economy in multiple ways. At this junction, I feel appropriate to pause my deliberations. Thank you. Thank you for listening me.
Thank you, sir. About the participant, any question? कोणाला काही क्वेश्चन असेल तर विचारू शकता.
No, sir.
Yes, please ask.
So how was it, sir? Please again.
Okay, sir, no problem. Now the word of thanks. On behalf of HRDC Malia Mission Teacher Training Center, Dr. Baba Sahib Ambedkar Marathwada University, Chhatrapati Sambhaji Nagar, I Professor Mudassir from the Department of Chemistry, MGV's Arts, Commerce and Science College, Malegaon City, Autonomous. Respected chief guest, esteemed resource person, Dr. J. A. Kulkarni, sir, coordinator, faculty member, and dear participants. At the outset, on behalf of organizing committee, I express my deep sense of gratitude to all those who have directly or indirectly contributed to the successful completion of this session. First and foremost, I extend my sincere and heartfelt thanks to our esteemed resource person, Dr. J. A. Kulkarni sir, for graciously accepting our invitation and for sharing their vast knowledge, experience, and valuable insights during the session. The expert lectures, practical orientation, and thoughtful interactions have greatly enriched the academic and understanding of all participants and made this session truly meaningful. My sincere thanks go to course coordinator for their meticulous planning, academic leadership, and tireless efforts in organizing and coordinating all the activities of the session. I also appreciate the dedicated efforts of all faculty members and organizing committee members who work behind the scenes to ensure the success of this session. I would like to acknowledge the valuable support extended by the technical staff for their cooperation in the handling technical, administrative, and logical arrangement. I extend my special thanks to all the participants for their active participation, enthusiasm, and keen interest throughout the session. Your involvement and interaction made the session lively and rewarding. Finally, I thanks everyone who contributed it anyway to make this short-term course a grand success. I hope the knowledge and skill gained during this program will be useful in your academic and professional journey. Thank you all once again. Thank you. Thank you very much. The session is ended here, sir.
Thank you all.
Thank you.
Thank you for patient hearing. Have a nice day.
Okay, okay. Thank you.